Okay. I'm going to do the initial preliminary test to make sure that everything is working well first. And just in case you can skip to a further end of the video, because this part is just to make sure that the live stream does not have any hiccup. Okay, audio. Now camera angle is not good. Okay, I think this is. Let me mute this one. Since audio is working okay. Okay, we are now going to begin the live stream. The problem now is the board is not showing as good as it used to show before, and also my face. My face isn't showing that well. Okay, you know what time it is now, right? This is time for MTH 111 test 2 mass review. So what I'm going to do right is just do the beginning part. Okay. Um you guys complained last video, the people that watched it, they said the video was too long, 2 hours, something minutes, that instead I should try and tone down the size of the video. I tried to explain to them that it is based on what is inside the video. There are plenty things. I didn't just solve the questions, I explained in-depth knowledge into the questions. I explained it as best as I could, so that if you watch that video alone, you'll be able to solve any question that comes out in that lane. In case there's anyone that I missed, you can still tell me. But I made the way that you can solve every single question that comes from all topics that treated before test one. That's the thing that I'm going to do for this video. So in case this video is turns out to be too long for you, then there's no problem. You can choose not to watch the video. But that's the thing I'm going to do for this video. I'm going to make sure that every single topic that came out after test one, in test two, every single topic will be explained in this video. That I'm not just going to solve to get the answer. I'm going to explain this topic as much as I can. So let's begin from test one. Let me confirm something from this my feedback. As those boys know, I used to watch the live by myself or with myself. I used to watch it to make sure that everything is going. Because for now I'm the only person doing it, so for now I don't have a team that is with me that will check all these things. So I'm not checking by myself. Okay, I think this is good enough. This part of the board is not showing, so let me mark it out. So I'm not writing anything on top here. Part of the board is not showing. Okay, so let's begin. The first question there, please, as I said, okay, let's begin. Let's start from the introduction, the introduction to the video. Big thank you to Mr. Bola for helping me thus far with the whiteboard and book preparation and everything. Thank you to the math department that I'm using, that sent question on the math department. I love them so much. Thank you. Thank you to the school. Thank you to the school. Thank you to everybody. Thank you to the people that came saying that they watched the video. Thank you to the people that started calling me review because I called it review. Who calls a video review for Christ's sake? But I called the video review. People started calling me review. Thank you to everybody entirely. Thank you to okay, my face is not showing. Okay. Thank you to Domit. Thank you to who thanks needs. Okay, let's begin. Question one. Please bring out your past question. Please bring out your test question so we can flow together. Question one says, which of the following is the correct partial fraction decomposition of 3x? Let me confirm my audio is working. Perfect. Following immediately. Okay, which of the following is the correct partial fraction decomposition of 3x plus 5 divided by 2x squared minus 5x minus 3. You know, it's one thing to know how to solve this particular question, and it's one thing to know how to solve any partial fraction that they give out to you. So please, I'm going to explain this thing in-depthly. So don't come to watch this video saying that, oh, just want to know the answers to the test one question, the test two question. No. Come to watch this video that by the time you're watching this video to the ending, you are going to understand all the topics that were taught between test one and test two. Okay. Now, to solve a partial fraction, there are different forms that partial fraction can come out in. If the denominator is just a form of a linear form, ax plus b, then your partial decomposition will just be in that form. You have capital A divided by ax plus b. So if you have f of x on top of here, the partial breakdown will just be a divided by ax plus b. With that same idea, if you have ax plus b times cx plus d in the denominator, that is, you have two linear factors multiplying each other. We are representing it. Oh, this barrel is new. No one that was looking at me like I stole when I carried the thing from the table. This one is new, very, very new. So I have to use it with caution. Okay, you can now break it down to a divided by, let me write down all of them. Let me write down all of them. If you have f of x divided by two linears, let's say x plus a times x plus b, this would equal to a divided by x plus a plus b divided by x plus b. If you have another one, f of x divided by x plus a to the power of n, it will equal to a divided by x plus a plus b divided by x plus a all squared plus c divided by x plus a power 3 plus d, no, I just want to say plus dot 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 plus d divided by x plus a to the power of n. What I mean here is that if you have a function divided by x plus a to the power of n, you first of all start from x plus a to the power of 1 plus b divided by x plus a squared plus c divided by x plus a cubed. Now, if this n here, let's say you have 2 divided by x plus 1 all squared, the partial breakdown will be a divided by x plus 1 plus b divided by x plus 1 all squared. If here was cubed, you add c divided by x plus 1 cubed. If here was power of 4, you add d to the power of d divided by x plus 1 to the power of 4. That's what I mean by this recursive function here. If you have f of x divided by x plus a to the power of n, you first write x plus a, then x plus a all squared plus x plus a cubed plus x plus n all the way to x plus a to the power of n. Another one that I think I know is if you have f of x divided by ax squared plus bx plus c. That is, this quadratic cannot be written in its factor form. This is unfactorizable. You cannot factor this. You cannot factor this. My face is not showing, so please don't think that I purposely made my neck cut out. So the board will show, more of the board will show. That's why. Okay. If you have f of x divided by ax squared plus bx plus c, where ax squared plus bx plus c cannot be written as x plus a times x plus b, what you write now is going to be ax plus b divided by ax squared plus bx plus c. That is, what I just did here was to remove, since the highest power here is x squared, I reduced it by 1, making it x. So you have ax plus b divided by x squared plus bx plus c. Now, if you have, let us say you have f of x divided by maybe ax plus b times maybe ax squared, no, I did it for maybe cx squared plus dx plus e. This will not be written as, don't forget, when you have this times this, you just put the first one plus the second one. So in this case, we have a divided by the first one, ax plus b, plus capital B divided by the second one, cx squared plus dx plus e. That is simply just what it is. It's just in a way that by the time you add these two fractions together, you get the same denominator here. Don't forget the LCM of x plus a and x plus b is just x plus a and x plus b. The factors of x plus a and x plus a squared and x plus a cubed and x plus 8 power of n, all those will be x plus 8 power of n, because x plus a is also a factor of x plus 8 power of n. The factor of ax squared plus bx plus c is still going to be same thing here. Then the factors of ax plus b and cx squared plus dx plus e is going to be the factor here. It's going to be the denominator here. That's just this idea. I don't know if there's more, but these are the ones I can remember for now. So let's try and solve this question using this. Please copy down, copy down. Hello. Please copy down. Okay. We're going. Hello. Without test, please. Just don't enter the camera if you don't have a picture. You want to use question? Yeah, no problem. I don't want to use question. I'm going to do the lecture, but I'm not doing it. I'm starting from the bond. Okay. Don't stay at watch the video. Okay, you want to stay this, you can stay on just 50 Okay. Question 1 now. Let's answer question 1. We have 3x plus 5 divided by 2x squared minus 5x minus 3. Now to solve this, as I said, you have to check, is this denominator factorizable? Is 2x squared minus 5x minus 3 factorizable? That's the first thing you check. You have 2x squared minus 5. Okay, I said I'm not going to use this marker excessively because that one is new. So let's try the old markers. We have 2x squared minus 5x minus 3. Is this factorizable? To check this factorizable, you bring this down. 2 times minus 3 is minus 6. What two numbers will multiply together to give you minus 6? But when you add them together, you get minus 5. That is simply just going to be minus 3 and minus 2. You now put it down here. No, 1 and 6. 1 and 6. Yes, so that's true. No, that's true. I think that's true. Can two of them work? Yeah. Okay, no, this times this will give you plus 6, but you're right. It's supposed to be plus 6 and minus. No, minus 6 and plus 1. Yeah, sure, don't show your face. Let me know you're smart person asking this thing. Okay, I have minus 6. Minus 6. Two numbers that will multiply to give you minus 6 is minus 6 and plus 1. And when you add them together, you get minus 5. Minus 5. And there's no actual need to do all these things because of, if you check, it's OBJ for the 100 levels. It's OBJ, so there's no need to do all this. If you check the options, all the options will be, will give you the denominators already. X minus 3 and 2x plus 1. But let's just continue. I'm just saying, in case you don't know how to factorize, even though I taught factorization in the other video, but in case you don't know how to factorize, then you can just use the option. You check the denominators. The denominators are x minus 3 and 2x plus 1. Then this will be the factors. But let's continue. We have 2x squared minus 6x plus x minus 3. If you factorize this, you have 2x bracket open x minus 3 plus 1 bracket open x minus 3. Finish the factorization. You have 2. Okay, showing on the screen. You have 2x plus 1 times x minus 3. So this will be 2 factors. As I said, it will correlate with the option. You can see all the options have x minus 3 and 2x plus 1. X minus 3, 2x plus 1, x minus 3, 2x plus 1. Okay, only option A and option D has x minus 3 and 2x plus 1. Option B is x plus 3 and 2x plus 3. Option C is x minus 3 and 2x minus 3. So immediately, you can just cancel out B and C from the options. Immediately, right now, you can just cancel out B and C from the option because B and C don't have denominators that will multiply together and give you the factor of 2x plus 1 and x minus 3. So immediately, these are ways you can cancel out options. So now your chance of getting this question instead of 20%, your chance of getting the answer correct is going to be 33% now. And that none of the above was not there, then your chance of getting this question now will be 50% just by doing this factorization. So now, the second thing to do now in this question, it seems to have clean factors already, but no, I'm the question here. But the second thing to do now is to represent this as is partial fraction. Now, there's a name I'm going to just call it now, which I don't know the correct name, but let's just call it the incomplete partial fraction. That is, we're using the variables A, B, C, D. By using those variables, then let us call it the incomplete partial fraction. It's not the actual name, I don't know the actual name, but so we'll be able to flow. So now let's represent this as incomplete partial fraction. I give you the formulas here, the formulas or the identity that you can use, or the reasoning behind it. So now the factors here are x minus 3 and 2x plus 1. So we have capital A. Push, let's see if I'll just do this in marker. We have capital A divided by x minus 3 plus capital B divided by 2x plus 1. Since now we're not written this in its incomplete partial fraction, and I said before, just to clarify, that is not the actual name. Incomplete partial fraction is not the actual name, but so I'll be able to flow instead of calling it partial fraction because this is not the complete way of presenting partial fraction. So let's continue. Since we know this is the incomplete partial fraction, let's try and guess what this numerator will be. So if we join the fractions together, I showed you how to add two fractions in the other video. How to add, instead of adding only numbers, how to add with letters. So add with letters, we multiply the denominators. So we have x minus 3 times 2x. I don't know if it's the new one. You can read. I think that I don't want to get something that. Okay, so we have x minus 3 times 2x plus 1. Now with the numerator, I told you before that adding these two things, you carry the numerator here, divided by the numerator here, times the numerator here. So we have x minus 3 times 2x plus 1 divided by x minus 3, that will be root 2x plus 1 times a. That is a bracket 2x plus 1. Plus, you carry the numerator here, divided by the numerator here, times b. So that is x minus 3 times 2x plus 1 divided by 2x plus 1, that will give you x minus 3 times b, that is b times x minus 3. All this is equal to this right here. Now, if you notice, the denominator here is the same as the denominator here. So we can just cancel them out. Okay, the top part of this video, the top part here. Okay, this part does not show well, but this is B. I'm seeing the video now. This part does not show well, but this is B that I wrote here. The denominator here is equal to the denominator here, so you can just cancel them out. This will cancel out this. Leaving you with 3x plus 5 is equal to a bracket 2x plus 1 plus b bracket x minus 3. Okay, anybody have anybody joined? Nobody. What do you mean? Okay, now you have to expand this out. That will be 2ax. No. Let me just start. Let me show you all the methods you can use to solve this. Now, from this point in time, you can say let x equal to 3. Then b will cancel out. If you say let x equal to minus 1 over. Okay, the reason why b cancels out is because we want to make x minus 3 0. So let x minus 3 equal to 0. Then x is equal to 3. So you can say let x equal to 3 and this b will cancel out. That will now leave you with a. So you can get the value of a. Then if you say let x equal to minus 1 over 2, then a will cancel out. That will leave you the value of b. In fact, you know what? I will use that method and solve this question. Then I will use the second method and solve the next question. That way I'm not going to make the video too long. So using this first method, we have let x equal to 3. If we say let x equal to 3, then here will become 3 times 3 plus 5 is equal to a times 2 times 3 plus 1. Okay, if we may not use the dot, but let's call it one multiplication, plus b bracket 3 minus 3. 3 times 3, that is 9. 9 plus 5, that is 14. Is equal to a bracket 2 times 3, that is 6 plus 1, that is 7. Plus b bracket 0. B times 0, that is just 0. So we are left with 14 is equal to 7a. This implies that a is equal to 14 divided by 7, which is equal to 2. Simple like that. A is equal to 2. But that's not all. We still need to find the variable b to make this a complete solution. But okay, okay, okay. I just wanted to just check, to make your work faster, because we're looking for speed and accuracy. To make your work faster, to check the options, you see that here is the one that is the second place. So you have to find the value of b. Because we already said B and C are not the part of the options. So you have to solve, get the value of b. If b is plus 1, then A will be the answer. If b is minus 1, then D will be the answer. But since I've already solved for A, then there's no problem. But I'm just saying, if you want to solve the thing faster, first of all, you factorize. Then cancel the options that don't have the correct factors. So we cancel B and C from here. Then remaining A and D bar. Then you now solve for the second term. Don't solve for the first term, because the first term is always going to be the same, 2 and 2. You solve for the second term. If that place is positive, then you know the first option is correct. If it's negative, then the second option is correct. But in this case, I've already solved for A. But let us continue. To cancel out A now, we say let x equal to minus 1 over 2. It's minus 1 over 2 because 2x plus 1 should equal to 0. 2x is equal to minus 1. So x is going to equal to minus 1 over 2. So let x equal to minus 1 over 2. We have 3 times minus 1 over 2 here plus 5 is equal to a bracket 2 times minus 1 over 2 plus 1 plus b bracket minus 1 over 2 minus 3. 3 times minus 1 over 2, that is minus 3 over 2 plus 5 is equal to a bracket 2 times minus 1 over 2, that is minus 1. Minus 1 plus 1, that is 0. Plus b bracket minus a half minus 3, that is minus 7 over 2. Minus 3 over 2 plus 10, that is minus 7 over 2 is equal to 0 plus 0 minus 7 over 2b. Minus 7 over 2 cancel out minus 7 over 2, we are left with b is equal to 1. So now we know the value of a and we know the value of b. If you put that, okay, no, the thing is shaking now. Okay. If you put this value of b and a back into this incomplete partial fraction, you have. Are you talking about?
No, I'm
Okay.
trying to get.
If you put back this value of a and b into this incomplete partial fraction, we will get that a is equal to 2 and b is equal to 1. Calm down. Sorry. Minus 3 over 2 plus 5 is equal to plus 7 over 2. Minus 3 over 2 plus 5 is equal to plus 7 over 2. I'll draw it. If you divide both sides by minus 7 over 2, you get minus 1 here. So b is equal to minus 1. So you have 2 divided by x minus 3 minus 1 divided by 2x plus 1. That will leave you with option D as the correct option. I will go through it again because I made this mistake. And we have 3x plus 5 divided by 2x squared minus 5x minus 3. The first thing we'll do is to find out its incomplete partial fraction, which we agreed on was a divided by x minus 3 plus b divided by 2x plus 1. We now join those two partial fractions, those two incomplete partial fractions together to leave you with a times 2x plus 1 plus b times x minus 3, all divided by x minus 3 times 2x plus 1. We agreed that, or we already know that x minus 3 times 2x plus 1 is the same thing as 2x squared minus 5x minus 3. So we can cancel that out, say they are equal. We have 3x plus 5 is now equal to a times 2x plus 1 plus b times x minus 3. That is, the numerators are equal. We now say let x equal to 3. And we say let x equal to 3, so we want to cancel out b, leaving us with a. To cancel out a and cancel out b, we say let x equal to 3. So 3 times 3. So everywhere you see x here, you put in 3. 3 times 3 plus 5 will give you 14. A times 2x plus 1, that's 8 times 7, plus b cancels out. If you divide both sides by 7, you have a is going to equal to 2. Let x equal to minus 1 over 2 now. You put it inside the function and you get plus 7 over 2 is equal to minus 7 over 2b. Divide both sides by minus 7 over 2 and you get b is equal to minus 1. If you put in those two values, b equals to minus 1 and a equals to 2, into this our incomplete partial fraction, you get 2 divided by x minus 3 minus 1 divided by 2x plus 1 as our partial fraction, and that's option D. So that is correct. Let's go to the second question now. I believe I gave you enough time to copy down, so please, don't copy down, sorry. Okay. Any viewer? No. Okay, let's solve question 2. Let's attempt question 2. Okay, question 2 now says, well, let me write it down with these black markers. Question 2 says we should express x divided by x squared minus x plus 1 times 3x minus 2. The first thing to do is to determine what is the incomplete partial fraction for this. First of all, you check, is x squared minus x plus 1 factorizable? The answer is no. You can try that by yourself. Check if x squared minus x plus 1 is factorizable. The answer is no. And the reason why I can probably say it's no is because in the option, there is no factor for x squared minus x plus 1. All the options have x squared minus x plus 1 and 3x minus 1 and 3x minus 2. So x squared minus x plus 1, I can say it that it's not going to be factorizable. Okay. Now you have to look for the way to represent x squared minus x plus 1 times 3x minus 2 as its incomplete partial fraction. And I told you that last time that if you have two numbers multiplied like this, it will be in the first number here plus the second number here. The first number is x, or the first expression is x squared minus x plus 1. The second expression is 3x minus 2. This first expression has the power of 2. The power, okay, this expression, I've seen where the line stops. The line stops here. The video cannot record past here. Okay, the power of the numerator here is x squared. So the power of the numerator should be 1 less of it. So since the power here is 2, the power in the numerator must be 1. So you have a capital AX plus B. That's if let's say the denominator had the power of, let's say, 7, and x power of 7 plus maybe x plus 1. X power of 7 plus x plus 1. The numerator now be capital A. Since the power here is 7, the power on top will be 6. So capital A x to the power of 6 plus capital B x to the power of 5 plus capital C x to the power of 4. You understand? All the way down to ABC. The power of 3 will be D, power of 4, then power of 2 will be E, power of 1 will be F, and G. So all the way down to plus G. And G will not have X, G will just be a constant. All the way down to plus G. So for this one now, we have the power of the denominator, that is the highest power of the numerator. The degree of this polynomial at the denominator is power of 2. The degree of 2 has a degree of 2. So the degree of the numerator must be the degree of 1. So you start from AX plus B. For the second one, and the power is 1. So the power of the numerator should be power of 0. So you are starting with the constant, and that's just C. And when you are starting with the constant, you are also ending with the constant. That's just it. If you are starting with power of x here, you are still ending with the constant. So if you are starting with constant, you are ending with the constant. So you have ax plus b, all divided by x squared minus x plus 1 plus c divided by 3x minus 2. Now, since now I've gotten its incomplete partial fraction, you do the same process again. You divide, that is long division, write down the LCM or the denominators, that is x squared minus x plus 1 times 3x minus 2. Then you have denominator here divided by the numerator here times the numerator. So you have x squared minus x plus 1 times 3x minus 2 divided by x squared minus x plus 1. X squared minus x will not cancel out, leaving you with 3x minus 2 times ax plus b. So you have ax plus b times 3x minus 2 plus c times x squared minus x plus 1. I'm very sure you already know why it's c times x squared minus x plus 1. So there's no need for me to explain that again. Now this is equal to, okay, let's first of all cancel. This is equal to this, so they can cancel out. That will leave you with x is that numerator here, x is equal to ax plus b times 3x minus 2 plus c bracket x squared minus x plus 1. Push. Now you can say, okay, I agree that I'm going to teach you with the second method in this case. Then in the first method, you are going to say let x equal to 2 over 3. Then this will cancel out, leaving you with this. You can now get the value of c. Then the second thing you now do is say let x equal to 0. If x equals to 0, then a will cancel out, leaving you with b and c. But since you know the value of c already, you can get the value of b. So we got the value of b. Then the third one now is to say let x equal to 1. If you say let x equal to 1, then b will be here, a will be there, and c will be here. But you already have the value of b and c, so you can get the value of a from that. Check, check, check. If you still want me to teach you the method for this one, then you can please. Either you meet me in person, you comment it down, and I'll do that process here. But I'll show you the second method. The second method is comparing coefficients. That is compare of coefficients. And in this method, we have to expand this bracket. So you have ax bracket 3x minus 2 plus b bracket 3x minus 2 plus c bracket x squared minus x plus 1. Expand the bracket and you have 3ax squared minus ax plus 3bx minus 2b. You have 3ax squared minus 2ax, no, minus 2ax, sorry. 3ax squared minus 2ax plus 3bx minus 2b plus cx squared minus cx plus c. Yes. So now you bring all the terms that x squared together. You have 3ax squared plus cx squared. Bring all the terms that x, you have minus 2ax plus 3bx minus cx. Bring all the constants together, you have minus 2b plus c. All this is equal to x. Now what you do is to compare the coefficients in the left hand side with the coefficients in the right hand side. All the terms that x squared in the left hand side is 0. So 0 is equal to all the terms that have x squared in the right hand side, that is 3a plus c. So this is x squared. Do the same thing for x. And all the terms that have x in the left hand side, that is just 1, is equal to all the terms that have x in the right hand side, that is minus 2a plus 3b minus c. Minus 2a plus 3b minus c. Then you have the same thing for the constants. All the constants in the left hand side is simply just 0. So 0 is equal to all the constants in the right hand side. And that is equal to minus 2b plus c. So now you have 3 simultaneous equations to solve. And this simultaneous equation is not the same like the normal ones you are used in secondary school. I'm sure the normal simultaneous equation that you are used in secondary school is you will see something like maybe 2a plus c, and then you see something like maybe 2c plus a. That tell you, okay, what you do is to multiply here by 2, you now get 4a plus 2c, then subtract. In this term, you can start here, you have b and c, there's no a. In this case, you have a and c, there's no b. So a little bit, something that you have to think deep in. So the first thing I want to do, let's name these equations to make it easier in solving the question. Let's name them. This is equation 1, equation 2, and equation 3. And in case my answer is not good enough, let me see it. 0 is equal to 3a plus c, 1 is equal to minus 2a plus 3b minus c, and 0 is equal to minus 2b plus c. So now let me solve this simultaneous equation. You have to solve this simultaneous equation before you can move forward. Let me check if everybody is doing first. Okay, still no viewer. Okay, I'm trusting on Jameson to post. I just called his name. I'm sorry, Jameson, but I'm trusting on him to post the link. But it's like it's not online, so let me just do that by myself. Okay, done. Okay, let's solve this simultaneous equation. So now the first one I want to do is to call equation 3. If you recall equation 3, you have 0 is equal to minus 2b plus c. If you move this minus 2b to the left hand side, you have c is equal to 2b. C is equal to 2b. Let's call this equation 4 because it's going to be very important. Since you know that c is equal to 2b, can we do anything with that? C is equal to 2b. Yes, we can do something with that. Put this c equal to 2b into equation 1 and equation 4 and equation 2. Now, c equals to 2b is gotten from equation 3. So if you put inside equation 3, it doesn't mean nothing. If you put c equals to 2b, you just get 0 is equal to minus 2b plus 2b. That is 0 is equal to 0. It does not change anything. So you put in this c equals to 2b into equation 1 and equation 2. Put inside equation 1, you have 0. Put inside equation 1, you have 0 is equal to 3a plus 2b. Because c is equal to 2b, so you have 3a plus 2b. Put inside equation 2, you have 1 is equal to minus 2a plus 3b minus 2b. Put inside equation 2, you have 1 is equal to minus 2a plus 3b minus c. But c is equal to 2b, so you have 1 is equal to minus 2a plus 3b minus 2b. Let's simplify. You have 1 is equal to minus 2a plus b. Now, perfectly, we have these two expressions, 1 and 2. This is now in the form that we all know in secondary school. This form is the easiest form. I love this kind of form. In this form now, you can solve it very, very simply using substitution method or elimination method. So you have 0 is equal to 3a plus 2b and 1 is equal to minus 2a plus b. So the method I want to use is the elimination method because I really love the elimination method. Even though I know substitution method is higher than elimination method, I'm not going to argue that with anybody, but I know substitution method is higher than elimination method, but I really love the elimination method because it's easier for me. So let's multiply this equation by 2, multiply this equation by 1, and subtract them. So we have 2 is equal to minus 4a plus 2b. And the second one is 0 is equal to 3a plus 2b. I'm very sure you know what I did here. I multiply this one by 2. You have 2 is equal to minus 4a plus 2b. Then I wrote down this one here, multiplied by 1. So 0 means the same thing. 0 is equal to 3a plus 2b. Then I subtract. 2 minus 0, that is 2, is equal to 2 is equal to minus 4a minus 3a, that is minus 7a, plus 2b minus 2b, that is 0. So you have 2 divided by minus 7 is equal to a. Well, let me not skip step. You have 2 is equal to minus 7a. Therefore, 2 divided by minus 7 is equal to a. This implies that a is equal to minus 2 over 7. Easy like that. A is equal to minus 2 over 7. Now, since we know the value of a, we can get the value of b using this expression. And if we get the value of b from here, we can now get the value of c using this expression. Everything is just a chain reaction. I don't know if chain reaction is correct, but everything is just the moment you get one, you can get another one. You cannot get the final one. In fact, you can even use this expression and put it in equation 1 and get the value of c. Whichever one, once you have found one value, you can get as much value as possible. Okay, let's put inside this expression, or let's pick the easier one. Let's put inside this expression. We have from expression 1, we have 3a plus c is equal to 0. So c is equal to minus 3a. C is equal to minus 3 times minus 2 over 7. Therefore, c is equal to 6 over 7. I'm not going to do it. I wanted to do it. I don't know what brain was just to my head. I was the one doing it, but I'm not going to do it. But c is equal to 6/7. Okay? The next one now we have c is equal to 2b. Okay, this expression, let's put the box around it. A is equal to that, c is equal to this, and b. C is equal to 2b. Therefore, b is equal to c over 2. B is equal to 6 over 7 divided by 2. B is equal to 3 over 7. Let's put the box around that also. So now I've gotten our values for A, B, and C. Let me check if the video showed. Yes, it showed. So we have gotten our values for A, B, and C. Don't forget that I got the value of A and B. Let's not put that solution. You have to put that value of A, B, and C back into the expression. So if you put that back into the expression, let me write it down here. If you put it back into the expression, you have minus 2 over 7x plus 3 over 7 all divided by x squared minus x plus 1 plus c is equal to 6 over 7 all divided by 3x minus 2. 7 is common here and 7 is common here. So you can bring that all down to the numerator and you have minus 2x plus 3 divided by 7 times x squared minus x plus 1 plus 6, and this will be your solution. You have minus 2x plus 3 divided by 7 brackets x minus x plus 1 plus 6 divided by 7 brackets 3x minus 2, and that is option A. Minus 2x plus 3 divided by 7 brackets x squared minus x plus 1 plus 6 divided by 7 here. Now, as I said, I'm going to show you people. I want to try my best to show you people short method in solving this. And I think the only short method I can see in solving it is getting each value one step at a time. That's like going to the option, right? If you check, you will see that the option here, there is A, B, C, and D. One thing that makes them differ the most is the value of C. In option A and option C, the value of C here is 6. But in option B and D, the value of C is totally different, 1 and 3. So if you get the value of C first of all, that is the first thing you solve for, is value of C. Then you will now determine if A or C is the correct option or B and D. One of them is correct. You understand? Then you now go again, solve for the value of A. That is, instead of solving the whole thing, just check the values, try to compare with the option. Okay, I've seen that option, that is the value of C differs in all of them. So the more you get the value of C for one of them, like you get the value of C, then you know which answer is going to be correct. I don't know if you get what I mean. That's why we solve for this one now. I've got the value of C to be 1, to be minus 1, sorry. What the value of C to be minus 1. There's no need to solve the question again. You know, your answer will be B. Let's say we solve again, we got our value of C to be minus 6. There's no need to solve again. You know that minus 6, that is option C, will be the answer. Let's say we solve and we got our value to be we got our value to be, yes, all the values are all different. If you got your value of C to be plus 6, then you know that option A will be the answer. If you got your value of C to be minus 1 over 7, then you know that B will be the answer. If you got your value of C, not 6, of C to be 6 over 7, sorry, minus 6 over 7, then you know that option C will be the answer. If you got your value of C, this C here, to be 3 over 7, then you know that option D will be the answer. Let's say your value of C was not in the option, then you know that E, which is none of the above, will be the answer. That's just it. I'm showing people, I'm not going to show people how to solve these questions because of time. I'm going to show people shortcuts in solving this question. So the first one, that is option A, question 1, I think we shortcut already. The shortcut is to factorize 2x squared minus 5x minus 3. By the time you factorize it, you will get two factored forms. That is, our one was x minus 3 and 2x plus 1. In that idea, if you check the option, the answer that you must get must have a factor of x minus 3 and 2x plus 1. And that is only option A and option D. So you know B and C are totally out of question. Or for question 3 now, the shortcut that I don't do now is to check the option. Which of the values that I'm looking for between A, B, and C are different in all the options? In this question, letter variable C is different in all of them. Option A, variable C is 6 over 7. Option B, variable C is minus 1 over 7. Option C, variable C is minus 6 over 7. And option D, variable C is 3 over 7. So you know you can solve for variable C. The moment you solve for C, right, you can get the correct option. You get what I mean? If you solve for C, you can get the correct option as I explained before. So that is the shortcut for this question 2. Let's go to question 3 now. Question 3 is where you really need this shortcut, where you really need a shortcut, because question 3 was really quite hard. But I'm going to allow you to copy down, copy. I started from here. I wrote down the incomplete partial fraction form. Then I brought them together. I cancelled the numerators. I expanded the brackets. I compared coefficients. I solved the quadratic equation. Then value of A and B, I put it back inside the expression, and I got the partial fraction. So let's go to question 3 right now. Okay. For question 3, question 3 right now is something that I know plenty of you would have said, oh, I don't know how to want us to solve 4 different partial fractions just to get the answer to one question. You don't know how to want us to do that. I know that this partial fraction is something that the moment you get the valid answer, you be like, okay, this is the closest to it, so this must be the correct answer. No, let me tell you, after this paper, let me tell you the truth. I told this one of my dummies for this question, right? It was just God that helped me. I totally guessed the answer. Guys, I went to questions. I don't know how the boys did this. I saw question A. I say this is wrong. I mean, option B, option B. I say this is wrong. I went to option C. This is wrong. I went to option D. This has to be like correct. So I now solved option D. I only solved option D in that example. I did not solve for A, B, C. I only solved for option D. And I solved for option D. I saw that everything was correct. I picked option D. You know what I mean, right? I don't see insecure is not for this. I don't know, but like, I'm like, I don't want to leave anything by chance. And that's correct. I don't want to leave anything by. So a normal me would have still gone back to test option A, B, and C to make sure that option A, B, and C is wrong. So that's why I made mistake with question D now, option D now, and option D was actually wrong. I would have failed that question. But a normal me would have gone back to cross check A, B, and C. But because of there was no time, I could not cross check A, B, and C. But fortunately, after the test, I went to go and cross check A, B, and C. And I'm not really with the paper that is here, but I'm telling you from the bottom of my heart that if you put it in the forms that you have to find A and B after A, B, and C, I realized that in these options, right, all the teacher did was just change one sign. That is, in the first one I solved, I think the answer was supposed to be like for option A, I think it was supposed to be 1 divided by minus 1 divided by x plus 2 all squared. I'm not sure, I can't remember, but it was supposed to be minus 1 divided by x plus 2 all squared. The teacher only changed the sign to plus 1 divided by x plus 2 all squared. Imagine this. Just imagine this. The first you solve for the first one, you go minus 1. Then in the option you're seeing plus. As you solve, you go minus. But in the option you're seeing plus. Obviously, somebody would have been like, this must be the correct answer. Maybe I made mistake. Maybe it's typo error. But I'm telling you the truth that this was wrong. This change in sign totally made this option wrong. I know some of you would have solved the other one. I think the other one, I think the answer was supposed to be. I'm not saying most of them were just change of sign from plus. The lecturer changed it to minus. From minus, the lecturer changed it to plus. I think there was only one question that the lecturer made A, B, and D, C. I'm not really sure. But there were just minor changes that they made to this question. So if you are going to follow this method, right, you can easily, you are prone to mistakes. You are prone to mistakes. If you saw, like I said last time, if you saw that you got minus 1 here, in the option you are saying plus 1, you will not be thinking that, oh, maybe it's typo error, you have to pick this. But no, that would be wrong. So the shortcut for this question, right? I'm not going to solve all the partial fraction. If you want to learn partial fraction, as I said, you can join the live now and tell me to solve them. But I'm not going to solve all the partial fraction because of time. Let me check how much time I've spent. Okay, 40 something minutes already. And I've already solved 2 questions. Okay, I'm not going to spend that much time. I'm not going to solve all the partial fraction. Instead, I'm going to just only solve with option D. And option D now, what I'm going to do with option D is to show you a shortcut in this partial fraction. That is, in case it gives this kind of question again, the question is like, the constant one is, which of the following correctly represents the partial fraction decomposition of a rational function whose denominator contains a repeated linear factor? So, to solve this, or to show you the solution to the question, I'm only going to prove that D is correct. I'm going to prove that D is correct. Now, to prove that D is correct, that is going to be shortcut method. Anytime you second question, what you do is carry the option, prove that option is correct. If that option turns out to not be 0 equals to 0, then that option is wrong. If you prove and check that option actually is 0 turns equal to 0, or maybe x equals to x, or something equals to something, then that answer is going to be correct. But if that thing does not form equality, then that answer is going to be wrong. Okay, so let's prove that D is correct. D says x squared plus 1 divided by x minus 1 all squared times x plus 1. Please, you can still meet me in person in case some things are not clear. Is equal to 1 divided by 2 bracket x minus 1 plus 1 divided by x minus 1 all squared plus 1 divided by 2 bracket x plus 1. Okay? Let's expand. Don't forget to first of all draw your long line. The factors of this is going to be x minus 1 all squared bracket x plus 1. There's no need to check it. The factors of all this must be the same as this, even though that option is going to be wrong, obviously. If the factors of the LCM of the numerators is not the same thing as the LCM here, then that question will be wrong. So this will be so if you divide this divided by this, you have 1 times x minus 1 times x plus 1 plus this divided by this, you have you have 2 bracket x plus 1 plus This divided by this, you have x minus 1 times x plus 1. No, you have x minus 1 squared. Yeah. Now let me confirm. You have 2x squared, 2x, you have 2 times x minus 1 all squared times x plus 1 divided by 2 times x minus 1. The 2's will cancel, one of the x minus 1 will cancel, leaving you with 1 times x minus 1 times x plus 1. Correct. The second case now, you have 2 times x minus 1 all squared times x plus 1. If you divide it with x minus 1 all squared, this x minus 1 all squared will cancel, leaving you with 2 times x plus 1, 2 times x plus 1 again. Correct. The third one now, you have 2 times x minus 1 all squared divided by 2 times x plus minus 1 all squared times x plus 1 divided by 2 times x plus 1. The 2 will cancel, the x plus 1 will cancel, leaving with x minus 1 all squared. So that's correct. Now let's expand our numerator. If you expand your numerator, you have x squared minus 1 plus, that is this part expands to x squared minus 1 plus 2x plus 2 plus x squared minus 2x plus 1, all divided by 2 bracket x minus 1 all squared times x plus 1. X minus 1 times x plus 1 will give you x squared minus 1. 2 times x plus 1 will give you 2x plus 1. X minus 1 all squared will give you x squared minus 2x plus 1. If you add everything together, you will have x squared plus x squared, that's 3x squared, minus 1 plus 1, sorry, minus 1 plus 2 plus 1 will give you plus 2. 2x minus 2x will give you plus 0. And that's all. So this 0 is irrelevant, so you can remove it. All divided by 2 bracket x minus 1 all squared bracket x plus 1. This is equal to, the 2's will cancel out, leaving with x squared plus 1 divided by x minus 1 all squared times x plus 1. This here is equal to this here. So this option D is correct. You have seen that x squared plus 1 divided by all this here is equal to this here. So you already know that option D is not correct. Now, I'm only going to prove that, maybe let me just randomly pick A, B, or C. Let me randomly pick maybe B. Let me pick the easiest one. Let me pick the easiest one. You know what? Let's just pick C. Since C is already on the page. Let's pick C. So now that I've proved that D is correct, I'm going to prove that C is wrong. In proving that C is wrong, I'm going to show you how the option will be. So if you know, so you know if this option is wrong or not. So right now this is correct because of everything, plus and plus, minus and minus. Now let's check for D. Let's check for C. Sorry, I'm going to clean right now. Let's check for C. Now I'm going to start C solution by writing it in blue marker because we're trying to prove that C is wrong. So let's start with this C, and C is written as, well, the expression for C is 3x minus 1 divided by x minus 1 all squared times x plus 2 is equal to 5 divided by 9 bracket x minus 1 plus 4 divided by 3 bracket x minus 1 all squared minus 5 divided by 9 bracket x plus 2. That's not right well. Yeah, not right well. It's been a watching. Okay, let me write it back. Let me write it in. Let me write it in the right name. So you have 3x minus 1, they say it's equal to 5 divided by 9 bracket x minus 1 plus 4 divided by 3 bracket x minus 1 all squared minus 5 divided by 9 bracket x plus 2. So the first thing you do is to draw your long line. You write down the LCM of 9 times x minus 1, 3 times x minus 1 all squared, and 9 times x plus 2. And the LCM will be 9 bracket x minus 1 all squared times x plus 2. Okay? Remember, I did the same thing I did in the last one. You carry the numerator here, divided by the numerator here times 5. 9x minus 1 all squared times x plus 2 divided by 9 times x minus 1. The 9 will cancel out. One of the x minus 1 will cancel out. That will leave you with x minus 1 times x plus 2 plus In this case now, 9, all this divided by this. 9 divided by 2, that is 3. Okay, sorry, this is supposed to be times 5. I forgot to times it by 5. So 9 divided by 3, that is 3. 3 times 4, that is 12. Times x minus 1 whole squared times x plus 1 divided by all this. That will leave you with x plus 2. Minus 9 divided by 9, that is 9. X minus 1 whole squared plus x plus 2 divided by this. That will leave you with minus 5 bracket x minus 1 whole squared. Let me confirm that nobody has joined. Okay, yeah, somebody has joined. Yay. Thank you for joining. I don't know if you can comment your name or your. Are you my dad? I think normally my dad is join my live stream apart from me. So please tell me your name or just say hi to know that you're. Never mind. Okay, expand the bracket. We have 9 times x minus 1 whole squared times x plus 2. Expand the bracket. We have 5. Okay, let me put in the bracket. We have 5x. No. How will I expand it that you understand? Let's expand it that way. Expand the bracket. We have x times x, that's x squared. X times 2, that's plus 2x. Minus 1 times x, that's minus x. Minus 1 times 2, that's minus 2. Plus 12x plus 24. It's 12x plus 24 because you have 12 times x, that's 12x. And 12 times 2, that's 24. Minus big bracket, 5 bracket. X minus 1 whole square is x squared minus 2x plus 1. Okay? Draw that long line again. Okay, still 2 zeros. That's me or somebody else. Okay, draw that long line again. We have 9 bracket x minus 1 whole squared times x plus 2. 5 times all this, that will give you 5x. Let me put in big bracket to avoid confusion. So the terms here will not mix the terms here. To avoid confusion, let me put in big bracket. We have 5x squared plus 10. No. 2x minus x, that's x. So 5 times x, that's 5x minus 10. Perfect. Minus 10. Plus 12x plus 24 minus 5x squared minus 10x plus 5. Now let's expand or let's cancel out terms. 5x squared here will cancel out minus 5x. Don't forget this is not just plus 5x. This is minus 5x. So 5x squared will cancel out minus 5x, leaving with 0 plus 5x plus 12x, that is 17x. 17x plus 10x, that is 27x. Let's do that again. 5x plus 12x, that's 17x. Minus 5 minus that is plus 10x, that is 20x, 27x. Minus 10 plus 24, let's write that out to avoid confusing me. 24 minus 10, that's 14. Minus 5, that's plus 9. Divided by 9 brackets, x minus 1. 9 by x minus 1 times x plus 2. Sorry for sneezing. Okay. This is irrelevant. 0 is irrelevant. If you divide now, you have 3x plus 3. Sorry, 9x. No, it's 3x. 3x plus 1. Yes, this 9 will divide. 3x plus 1 divided with x minus 1 all squared x plus 2. Now tell me that this is equal to this. It is not. I told you that what the lecturer did was just change one thing, change the plus, change the minus. They don't even change numbers, just change the plus. So small, just change small things into the expression, and they expect us to solve it in 30 minutes. So that's why I said, instead of going to solve all the partial fraction, instead use the option and try to prove if that option is correct or wrong. That would be a faster method to prove. I'm sure because I was teaching while explaining this thing, we see it's better to solve this than to do that. Try to get it's better to solve it this way than to try to get this. Than to try to get this from this. It's better to move from this to this than to try to get this to get to here. That's why, because if you are trying to get from here to here, then you have to do simultaneous equations. And it's not all simultaneous equations that is easy. Some simultaneous equations that are actually not that as easy as you think. Because it's easier to move from here to here. And if you move from here to here, you see that here is 3x plus 1. This plus, just one sign. Here is minus. That is all. And this is wrong. This is that little change in sign made this option totally wrong. Somebody may not have noticed this. Someone that would have solved would have seen that, oh, maybe I said before, someone that could have solved it. Because I'm saying it because of somebody told me that they thought that A was correct because they tried solving from A to D. They were not like, oh, thank you, Lord, thank you, Lord, thank you, Lord, that A was correct, that the first one they solved was correct. Not that the first one they solved had a little change of plus and minus, and they failed the question. So try your best not to, if you share your choice, if you want to solve all the partial fraction before them, you can go ahead, you can go ahead. It's a choice, it's a choice. If let me tell you the truth, if I had time, I would have solved all of them. So that there was no time at my end, and I told you I just did lucky guess. I solved what I did was just to prove that this option D was correct. That's what I did. And I said, option D worked. I went for it. But I'm telling you, like I have time, I should have solved it. But if you don't have time, like I believe we're not going to have, then it's better to prove, like move from the solution and get the question than to move from the question and get the solution. So now let's go to the next question to avoid waste of time. One funny thing about this next question, right, is because the day before this test, I'm not saying that this person, obviously, I'm not this university for Christ's sake, nobody can get your test question. But somebody had an insight from the Holy Spirit, very powerful man of God in mechanical engineering. He had an insight from the Holy Spirit, and as he was reading our notes, he saw this question in the note, and he could not solve the question. I don't know if he could solve the note, but like the next thing, I think it was chemistry class I was having. You don't know that on a piece of paper that after Igwe solve this question. Now I was looking at the question like, this is a different form than I've ever seen before. This is different, it's powerful. But how do we go about solving this question? Now, the question goes like this. The question goes like this. You have seen the question before, but it's x cubed plus 1 divided by x squared plus 1. I was fairly shocked when he said for me this question. I was like, true? How do I solve this kind of question? I'm seeing x cubed plus 1 divided by, there's nothing that cancels out. And the way I'm looking at it, I was like, this has to be wrong. But I asked another powerful man of math. Okay, man of God is a man of God, but powerful man of math, and that is, I don't know if I'm allowed to call his name, but according by his nickname, that is the source. My dormmate also, the powerful man of math, the source. I asked him, and when I saw the question, the answer that he got was the same as the one that I got. I said, oh, that means it is what it is. If that's how the answer is going to be for this question, then let it be so. It's not you that said the question, it's not that forced the question in. If that's how the answer will be for this question, then let it be so. I know the normal way I've seen partial fraction is in form of maybe a divided by x plus 1 plus b divided by x plus 2. This is the first time, let me not lie to anybody, this is the first time I'm seeing a question that the solution is x plus a divided by x plus 1. This is the first time I'm seeing a solution come in this form. I've always seen it come in the form of a divided by x plus 1 plus b divided by x plus 2. This is my first time I've seen it come in this form. That's why I was totally sure when I saw the question and I got the question in this form. I was like, did I make a mistake? Did I make a mistake? But I have just sent my solution back to him and he said, okay, I'm correct. Then he moved on. But okay. So that's I'm not saying in this story was that better rely on God, because I'm saying somebody solved this question a day before the test. He saw it in our part of our question, part of the practice question in notes. So rely on the Holy Spirit, rely on your notes, because some of them might giving question the notes, not knowing that this question will also come out in the test. That's what I always say. Practice questions, all the practice that our lecturer are sending, all the module things, they're not complete. All the assignment that say, fair enough, people have their submitted assignment now. Me, I've shall not on my own, but they're submitted assignment now. All these things are not complete. Do them. And my head is not showing, but do them. And let's solve the question. I'm going to solve this in two methods. Now I'm solving the second method because I promised you guys in the last video that I'm going to use this second method. But I don't actually end up doing it. I totally forgot. So after I did the live stream, and I remember that, hey, I promised I was going to do something. But I'm going to solve with two methods. The first method I'm going to do is the normal method, which I also did in the last video, which is the long division. I showed you how to do long division last video. So please go and check the last video. I showed how to do long division in the last video. But let's do that for people that already know how to do it. Let's practice long division. I told people that the numerator will become the driver of this long division. The numerator s squared plus 1 become the driver. Now, first of all, let's start with our train. Let's draw our train. The numerator will become the driver, we stay in the driver's seat. And while the numerator becomes the passenger, s cubed plus 1. Now, they are driving this s cubed plus 1 to, let's call it country, to Imo State. No, Imo State, not a country. But while they're driving this train to Imo State, S square plus 1 is the conductor, and S cube plus 1 is the people that are taking there. Now, if you have ever been to public transport, you will notice that there are some people that will enter inside, they call them along. That's as they are going, they now drop them off. Go, drop this one off, go, like that. So that's what we're going to use here. We have S square, S cube, that is you carry the biggest power. In fact, I said no, I'm not going to teach you how to do this thing. You go and watch the other video. S cube divided by S square, you have X. X times S square, that is X cube plus X. If you minus, you have, now these are people that you are letting off. These are people that you are dropping off. These are people that are going on the along express. That is S cube divided by S cube, 0. So S cube has left the chart. But by S cube, S cube has left the chart. Minus times X, that is minus X plus 1. S squared divided by, or X divided by S squared will not go because S squared has a higher power than X. So S cannot divide S squared. Instead, S squared has to divide X, but S cannot divide S squared because S squared has a higher power than X. So this cannot go. So this will be our remainder. This will be our quotient, and this will be our dividends. I think it's dividend they call it. So I can put it compound without waste time. But I believe it's dividend they call it. So this is our quotient, this is our remainder, and this is our dividends. How do you now write it? Let me show you how to write it. Now, if you have 6 divided by 5, you will get something like 1 remainder 1. If you want to express this as a mixed fraction, you have 1 plus 1 divided by 5. How do they get this? No, let me change numbers. To avoid confusion. Let me use 7 and 5. No, let me use 15 and 7. Yes, 15 and 7. This is 2 equal to 2 remainder 1. You write this as mixed fraction, that would be 2 plus 1 over 7. Now, how do they get this? What they simply did is the quotient plus the remainder divided by the dividend. So that's something they're going to do. S cubed plus S squared plus 1 is the same thing as yes. That's cool. Okay, it's the same thing as the quotient, which is X, plus this is that question that you wanted me to solve that time. I've already gone and started. No, question 4. I'm not starting. Oh, you read that. Okay. So rather than the quotient plus the remainder minus X plus 1 divided by the dividend S squared plus 1. Bam. Absolute cinema. I don't know what that meant, but I just said it. Okay, that's option B. X plus minus S plus 1 divided by S squared plus 1. Okay. No, somebody joined, but I thought this is comment his name or like something that will make me know like the class or the level or the course. But there's no answer. Okay. So we have X plus minus X plus 1 divided by S squared plus 1 as our answer B. Another way, right? But this is, if I was to solve this on a normal like in theory, there's an extra step I would have wanted you to take. Please don't take that step in this test because the test is already. But I'm just saying that in case you want to do this, maybe in 200 level, we are going to answer in theory. You're not going to do OBJ. In 200 level, please, what I want you to do is, instead of writing this one, please write it as X minus 1 divided by X squared plus 1. Nothing changed. All I did was factor out minus 1 from here to make sure that X is positive. Because we don't really like negative number, but to make sure that X is positive. Factor it out, you have X minus 1 divided by S squared plus 1. It's going to be the same answer. Okay, I don't leave it. If you still get your mark, it will be like just this minus bar. If you see minus 1 in a question, it's very easy for the lecturer to omit that minus sign. If it is not X minus 1, it's going to be very easy to omit that minus sign. So it's better you are going to put in a form where that minus either at the back, that's where you put in the form of X plus 1 minus X divided by X squared plus 1. So that minus will be at the back. Or entirely just factor out that minus 1. Factor that minus 1. So just try your best not to confuse whoever is marking your script. Because there are over how many students at this school. They are wasting time marking your script. You guys who me my bad handwriting. I know my best to put my handwriting so that they'll not come and cancel my script. But they are wasting time in my institution. They are wasting time in answering scripts. Just give you some kind of sweet X's. Appropriate. Yeah, that's an appropriate sweet X's. They don't have any bad meaning. So they'll not give you some kind of sweet X's. Cancel people and then move on to the next person. Yes, so everything showed in the video. I think so. This is X. I put in the box. Everything showed. Okay, let's go. Before I forget again, I promise you that I'm going to show you this method tomorrow in next video. Let me just use the second method. Now the second method, now we have X cubed plus 1 divided by x squared plus 1. I don't advise you to use this method every time. I only use this method whenever I'm solving some all these Olympiad questions that they are very hard to factorize and the rest. Now to do this, we say we are trying to look for something that will cancel out this x cube. X cube divided by x squared will leave us with, let me do my division, x squared plus 1. X cube divided by x squared will leave us with x, right? So now let's factor out x. Bracket open, x squared plus 1. Now x times x squared will leave you with x cube plus x. Yeah? Am I done? I think on that question, I'm not done with the waiting. I'm also show them another method for this question 4. I'm going to do number 5, number 6, number 7, number 8. If we may not end up to finish today, but well, as long as I'm giving, I'll continue. Okay, so now we are going now, right? Yeah.
I took the test one.
Test one, no, test one for me. Test one for Jameson. One of my guys.
Can I take it?
I'm not sure. I don't think you will agree. I'm not really sure because I've asked me to return. I'm not really sure. And he has not responded to the message yet. I don't think it's online. Okay. We can snap it to your device. Okay. So you first of all, right? X cube divided by x squared will give you x times the numerator here, that's x squared plus 1. And if you multiply this now, you get x cubed plus x. Yes. Minus 0, going my number, so 0, 8, 0, 8, 7, 1, 3, 60, 12. That's Telegram, WhatsApp, all of them. Yeah. eBay. The YouTube is IgweMatics.
Okay.
IgweMatics. Okay. Just send the message. So if you multiply them now, you get x cubed plus x. In this case now you have x cubed, but you don't have x. You have x cubed here. I'm sorry, you have x cubed here and x cubed here, but you don't have x. So to add x, so by adding x here, you have also minus x from here. I don't know if you understand what I'm saying. If you expand this bracket, you have x cubed plus x. There's x cubed here, there's x cubed here, good and fine. But there's no x, there's no x here, but x here. So to balance it up, since you're adding x here, you have to add that minus x. Don't forget that plus 1. So you have x bracket x squared plus 1 divided by x squared plus 1 minus x plus 1 divided by x squared plus 1. X squared plus 1 comes out x squared plus 1 here, giving you x plus minus x plus 1 divided by x squared plus 1. So this is the second method. Yeah, very awesome method. Now let's immediately move on to the next question. No question on the live chat, so let's move on to the next question. Question 5. Question 5 says a rational function with numerators. Good. We have a function with numerator x squared minus x plus 1 times 3x minus 2. Don't tell me. I think we saw this question before. X squared minus x plus 1. Don't tell me. Question 2. There's no way if you got question 2 correct. There's no way you are meant to do question 5. Because they are just expressed question 2. If you look at the options, they literally just that question 2 answers question 5. The options here, you have, let me see the question. The question won't show. One more option. The question is fine. But if you have the option like this, right, you've already seen the form that the options were in. The form that the options were in was a number times x plus another number divided by x squared minus x plus 1. Then the second number is now another number divided by 3x minus 2. So using that question 2, you could answer question 5. But even with, let's say no question 2. You should already know this. I showed you the 4 ways to expand to express partial fractions. So you should already know this. If you have a function divided by all this, you first of all write down the first number, that is this. Then write down this. No, first of all you check if this is factorizable. But this is not factorizable. So you write down the first number plus the second number. This now has the power of 2, so you add the power of minus 1 in the numerator. Since the power of 2 here, power minus 1, I'm sorry, power of 1 here, so that will be ax plus b. Since power of 1 here, power of 0 here, so that will be constant c. Okay, not really sure in the video. I can see the feedback of the video, so let me just make the camera up and restate what I just said now. So you write it down in this form. Why am I saying it again from the beginning? You should already know this now. But let me say it from the beginning again. You have this times this, so you write it down as okay, 3 viewers. Wow, 3 viewers. That's awesome. Let's try on the last last video on. Okay, so since you have this times this, you first of all write it as the first number x squared minus x plus 1 plus the second number 3x minus 2. So you now check the power here is the power of 2. So the numerator must have a power of 1. So you start ax plus b. The power here is power of 1. So the numerator here must have power of 2 and power of 0. S power of 0 is just 1. So that's just going to be constant. C. Let us say you don't have all this here, then the constant here will be A. Like you have to start it from A, B, C. In fact, you can even use it any amount, any way you want. If you can, if you want, you can put X, Y. Okay, no, there's already X here. If you want, you can put F, G, H. It's just the way that we've already known that A's are very hard to find. In like, if you cannot find A's down here. So that's why we have always been solving with A and B. But let us say they give you a question like maybe X divided by X plus capital A. Then please don't use A up here again. Use a variable that have not been used. Maybe you use U divided by X plus A. Use a variable that have not been used before to avoid confusing yourself. Don't forget I can still remember my primary school teacher. Back then in primary school, I was not good in math, but my primary school teacher always used to say something like, no, not in primary school, it was in WAEC. Do you know WAEC? They always say something like, be careful with your eyes, because when you're solving, your eye can be confused as one. Be careful with your, I don't know, you know all these things now. Be careful with your eyes. Be careful with your X, because your X can be confused as multiplication. So they always used to say all this, and that's true. Be careful with the kind of variables you use. That's why you hardly see me use small a to solve this. I always use capital A to avoid confusing myself. Let's go on to the next question quickly. Okay, that's option C. For this question, option C. Option A is wrong because you have cx plus d divided by 3x plus 2. That is wrong. The power of this place must be x minus m. Sorry, the power here minus 1. So the power here is 1, the power here must be 0. So that A is wrong. And B is wrong because the power here is s squared. The power that was up here was the constant. So it's supposed to be x, not the constant. So that's why B is wrong. For D now, D is wrong because they said 3x minus 2 all squared. It's supposed to be 3x minus 2 alone, not all squared. Let's quickly move on to question 6 because they're already chasing from LT. Let's try and see if we can solve all the questions right today. So question 6 now, we have Pythagorean identities. I am not going to teach you how to expand Pythagorean, how to derive the Pythagorean identity. But all I'm going to do is just from the first Pythagorean identity, which I'm very sure you all know already, something I've always been reciting, is sine square theta. You use theta here, yes. Sine square theta plus cos square theta is equal to 1. This is something that, okay, the board is not showing completely. If I turn here, will you show more? I think so, it's supposed to show more. If I turn here, no, it showed less. Turn here, show more. Show more. Okay, are you still working? Okay, it's working. Okay, perfect. So you have sine square theta plus cos square theta is equal to 1. These are our first Pythagorean identity. Something that we all know. We used to recite it every single time in primary school. So now, the first thing to do, since this is the first Pythagorean school, the first thing to do is to divide all through by cos square theta. If you divide all through by cos square theta, you have sine square theta plus cos square theta is equal to 1. Divide all through by cos square theta divided by cos square theta. So this can be separated as sine square theta divided by cos square theta plus cos square theta divided by cos square theta is equal to 1 over cos square theta. Cos square theta divided by cos square theta is equal to 1. Sin square theta divided by cos square theta is equal to tan square theta. But why is sin square theta divided by cos square theta equals to tan square theta? You should already know that tan theta is equal to sin theta over cos theta. So tan square theta should be equal to sin square theta over cos square theta. That's just what it is there. Sin square theta divided by cos square theta is not equal to tan square theta. But now what is now 1 divided by cos square theta? Don't forget your special angles, not those special angles. I don't know what they call them, but those other trig functions. Your special trig function, just don't forget your special trig function. You have cosec theta is equal to 1 over cos theta, and sec no, we have sec theta 1 2 3, this is c, so this is equal to 1 over cos theta. We have cosec theta 1 2 3, this is s, so this is equal to 1 over sine theta. 1, 2, 3, this is sec theta. 1, 2, 3, this is cos theta. 1, 2, 3, this is sec, and this is s. So this is sin theta. Sec theta is equal to 1 over cos theta, and cosec theta is equal to 1 over sin theta. Now, if you square this, we have sec square theta is equal to 1. Let me write that again. We have sec square theta is equal to 1 over cos square theta. If you square this, we have cosec square theta is equal to 1 over sin square theta. Good, now that we know all this, 1 divided by cos square theta is equal to sec square theta. And this is equal to sin square theta divided by cos square theta, that is tan square theta plus 1. So we have tan square theta plus 1 is equal to sec square theta. This is our second identity, number 2. Now let's go to the third one. For the third one, this first one we divide by cos square theta. For the third one, we're going to divide by sin square theta. So we have sin square theta plus cos square theta. Is equal to 1. Yes, I said. It's supposed to be my cosmate, but then I only have one more person. Oh, the person who left. So it's myself for now. But it's just they have their exam on Friday, so just something that they can use to review because nobody.
What are you using?
I'm using YouTube, sir.
Live?
Yes, I like. This camera, but I'm also watching just in case the.
It will record now.
YouTube
You record on YouTube. So you have a YouTube account.
account.
You will give me later. Let me watch it.
Thank you, sir. Thank you, sir. Okay. So let's divide by this one. We divide by cos square theta. So let's divide by sin square theta now. Sin square theta divided by sin square theta. If we divide by sin square theta, we're going to do the exact same thing. We have sin square theta divided by sin square theta plus cos square theta divided by sin square theta. This is equal to 1 over sin square theta. Sin square theta divided by cos square theta. Sin square theta divided by sin square theta. This is equal to 1. Cos square theta divided by sin square theta. This is equal to cos square theta. I forgot to say what cos square theta here. This is sec. This is cosec. Cos square theta is cos theta is equal to 1 over tan theta. That means cos theta is equal to cos theta over sin theta. So cos square theta divided by sin square theta is going to give you cos square theta. This is equal to 1 over sin square theta now is equal to what? Cosec square theta. Let's bring that all together. We have 1 plus cos square theta is going to be equal to cosec square theta. So these are our 3 identities. 3 special trig identities. The first one is sin square theta plus cos square theta is equal to 1. Sin square theta plus 1 is equal to sec square theta, and 1 plus cos square theta is equal to cosec square theta. Now let's look at our options. Option 1 says cos square theta is equal to 1 plus sin square theta. Does that make sense? No. Sorry for saying that. But we have C we have C is equal to 1 plus S. That is wrong. It's supposed to be S plus C is equal to 1. This is C is equal to 1 plus S. So this is wrong. Option A, wrong. Let's go to option B. Option B is 1 minus tan square theta is equal to cosec square theta. That is 1 minus tan. No, it's supposed to be 1 plus tan. So B is wrong. Option C now is cos square theta minus 1 is equal to, no, it's supposed to be cos square theta plus 1. So C is wrong. But let's go to option D now. Option D says cos square theta is equal to cosec square theta minus 1. Cos square theta is equal to cosec square theta. If you minus 1 from both sides, you have cos square theta is equal to cosec minus 1. So if you minus 1 from here, you have cos square theta is equal to cosec square theta minus 1. So option D is correct. Okay, did you show? Yes, I moved my body. Okay, I should. Okay, so A did not show clearly, but this was cancelled. A is wrong, B is wrong, C is wrong, and D is correct. Okay, people are watching now. Thank you for joining back the live stream. Thank you. Please subscribe. Really love the subscription. Okay, the James is responding. Nope, still have not seen my message, but no matter. I get back to style. Please subscribe. Love the subscription. So now let's go to option question C, question 7 now. Please, if you have any question on this, please don't forget. I know you don't want to comment or anything, but since you're the only person that is watching the live, if you have any question, please just say it so that I'll do this thing, respond quickly. Because your question, what really matters not about teacher, about the understanding. So your question will help me know if I made a mistake or if I need to add something to it. Because I want to make this video as packed as possible that once you watch this video, you are going to be set for the next exam. Except for complex numbers. There was no complex number inside this question. So complex number might be another maybe tomorrow. Maybe tomorrow, because I've not read the notes yet. I've not read any math notes yet. So I want to do this night. No, I can't read the maths. I have to focus on this night. But I'm not going to study, try to brush through the complex numbers and teach you what it is. That is if you demand for it. If people, I don't want to say, people tell me, oh, we need to do complex numbers. I'm going to do for complex numbers. Let me make sure that this video is recording. Okay, it's recording. I'm going to make sure that if people demand for the complex numbers, I'm going to do video for complex numbers, explaining the complex numbers. But for now, whoa, somebody you send one message. I'm not going to call your name because you're a female, I believe so. But yeah, my namesake, Igwe. And that's nice. Hello. Please, I'm going to respond to your message later because this video is very long. I'm only here because people are having tests and my guy is doing his own live stream too with his own students. So it's a live stream, back to back. Ah, why am I dancing? Why am I happy? Okay, the next question, let's go to the next question. The next question says, we have cot 25 degree times sine 25 degree times sec 25 degree. Everything here is in degree. Sorry, everything here is 25, 25, 25. So it's going to be cancelled, something to cancel out. Now, what I tell you about cot, I told you that cot is equal to cos theta divided by sin theta. So cos 25 degrees is going to equal to, just wanted to say thank you so much for your review. Somebody watch my video. Yes, somebody watch my video. I'm going to say thank you for your video. So I'm happy. So because of that, this night I'm going to cancel the physics I wanted to read. I'm going to cancel the everything I wanted to read this night is cancelled. This night I'm going to go and learn that complex number. I'm going to learn that inequality. I'm going to learn that absolute value. And tomorrow I'm going to ask Sabaola for permission to use the slides. I'm going to teach on the complex numbers, absolute value, and inequality. Because somebody said they watched my video, and that is good. One person out of the 10,000 students inside the school, but it's still progress. Okay, cos 25 degree is going to equal to cos 25 degree divided by sine 25 degree times sine 25 degree, just read as sine 25 degree. Sec 25 degree now is equal to 1 divided by cos 25 degree. That's 1 divided by cos 25 degree. Sine 25 degree will cancel out sine 25 degree here. Cos 25 degree will cancel out cos 25 degree here. So all this nonsense, math is not nonsense. All this beauty is all equal to 1. Uno. Uno, this is uno in, I think, Spanish. This is on in French. This is one in English. This is abo in Igbo. This is dayu in Hausa. This is utufi abuji in Yoruba. So this is all equal to 1. Now, I'll start reasoning this question in the exam hall. What if the answer was not 1? What if the answer was -1? But in case they tell you instead of 25 degree, let us say they said 125 degree. No. Math does not lie. The answer will still be the same. The answer will be the same. Because I was reasoning, what if this cos 20? What if it's like maybe sin 20 or sin 125 degree, and sin will have a negative in that place? But as long as you that way too, if sin is negative here, if sin is negative here, then sin will also be negative here. So that minus will cancel out. I don't know if you understand what I'm saying. I was reading the example that what if the answer was not just 1? Because as I saw 1 there, I saw -1. I was like, what if -1 is the correct answer? But then I'm just using it now. Right now, I'm just answering myself what I asked myself in the exam hall. This is like 2 weeks later. Then I'm slow. That's why I'm seeing the answer. But if sign is negative here, then this sign here will also be negative. And negative will cancel out with negative. If cos was negative, then the cos here will cancel out the negative sign, leaving you with +1. Because I was reasoning, what if what if it was a bigger number, maybe sign 125, which sign 125 is negative sign, ACTS. No, cos 125 will be negative sign. What if it's cos 125 now? I'll have a negative number, but then in the final solution, even if it's a negative number, that negative will cancel the other negative in the denominator, so you still get a positive number. So that is +1. Let's quickly move on to the next question. Okay. Question 8. This is another one. Now, let me just start with the story. From some time before test 2, right? Time for test 2, they were contemplating my dorm. That today, instead of learning how to prove this function, should they just cram these functions? I know we're against cramming. We're all against cramming, but their own form of cramming was memorize the function. I know it's still cramming, but their own was they claim that they can put the whole 20-something formula inside their head. I told them that no, me, I'm not going to do that method. The method me I want to follow is to learn how to prove this method so that I can prove it anywhere I go. Now, just like in maths, it's not everything in maths that is proved. Some things are axioms, and some things that we guess are true. Now, my own axiom in all these trig identities, my number one axiom, apart from sine squared theta plus cos theta equals to 1, that is my number one axiom for that case. But in this part of trig, my number one axiom is these 4 things. These are my 4 axioms, beautiful axioms, and beautiful axioms. These are my 4 axioms. These are in maths, these are not axioms though. These ones have already been proved already. So in maths, in like the general math, this is already proved. But for me, I don't know how to prove this. So these are my own axioms. Let me write axiom below because it's not showing well on the screen. These are my 4 axioms. Number 1, we have sine A plus B is equal to sine A cos B plus sine B cos A. 2, sine A minus B is equal to sine A cos B minus sine B cos A. 6 months I'm not eating me. Those are the ones that just slapped me. I don't finish it, so I can get it from country before I go. The next one is cos A plus B is equal to cos A cos B minus sine A sine B. Then the fourth one is cos A minus B is equal to cos A cos B plus sine A sine B. Perfect. These are our 4 axioms. The 4 things that I believe, I just guess, or not guess, but like I know in maths they are proved already, but like I just accept that they are true. I don't want to even learn how to prove it because the proof is in secondary, showed in secondary school was complex. It was too hard for me. So I don't want to know how to prove it. I just accept it that these guys are true. These are the 4 of them. From these 4, I can prove any, I said any other one. I'm not going to prove all of them. The one I'm going to prove the one that comes out in this, that came out in this test. Now let's prove the one that in the form of I think this is sum to product. Sum to product, I think. Okay. This one is almost sum to difference. This one is in this form already. It's the second one that is product to sum. So this one is already in this form. So we have the first one is cos A plus B is equal to sine no. Cos A plus B here is cos A plus B here is cos A cos B. Here is sine A. So that's option A. Wrong. B now is sine A plus B is equal to sine A cos B. Okay. Minus no. For sine is plus and plus. So B is wrong. Option C now is cos A minus B is equal to cos A cos B plus sine A sine B. So option C correct. The next one is sine A minus B is equal to cos A. No. Okay, yes, you can correct. Cos sine A minus B equal to sine A. Okay, sine A cos B minus. Yeah, they say plus. So option D is wrong. That's the switch signs in most of them. So option D is wrong. So question option C is the correct answer for this option for question 8. For question 8, option C is the correct answer. That is part of the axiom. So there's no need for me to solve in this question. Just write down the formulas, the actions that are already proved, and already known is true, and just put it there. But for question 9 now, there's none of them that is in this form. It's not in this form. For question 9 now, it is something like this, like a function f of x or f of b theta. Okay, yes, f of a times g of b is equal to half times something else. It's in this form. It's not in the form of cos this is equal to this times that. It's in that form entirely. So now what I'm going to do is to show the next 4. The way this part of trig, most of all the formulas come in pairs of 4s. This is the first 4. Let me show you the next 4. For the next 4 now, you have to pick 2 of these that are similar. If you look at this, sine A and sine A plus B and sine A minus B are similar. So let's pick the 2 of them. The first thing we do is to add the 2 of them. Let's call this equation 1. Let's call this equation 2. Let's call this equation 3. And let's call this equation 4. So the first thing I do is equation 1 plus equation 2. Equation 1 plus equation 2, that is sine A plus B plus sine A minus B. This is equal to sine A cos B plus sine B cos A plus sine A cos B minus sine B cos A. Sine B cos A will cancel out minus sine B cos A. True or true? True. And this now equal to 2 times sine A cos B. That is sine A cos B plus sine A cos B. So that will be 2 times sine A cos B. So therefore, we have sine A plus B plus sine A minus B is equal to 2 sine A cos B. Divide both sides by half. We have half sine A plus B plus sine A minus B is equal to sine A cos B. Okay. Now I'll put it in this form. This is the same thing you do for the remaining 3 to get the four formulas. I don't really know how I want to do this with the small space. I don't clean this. I don't clean this now. I don't know how I'm going to do with this small space. What I'm going to do is as I solve them, I will clean and use that same space to solve again. Is this thing clear? Okay, I think you can still letters now, except if you are if I don't see the letters, please zoom in. I believe that you can see letters. What I'm going to do now is to write down this our new identities. I'll write them here. So I'll use this small space to solve. I'll clean and solve again. So let me write down the identity. We have sine A plus B is equal to half sine A plus B plus sine A minus B. Perfect. Sine A plus B is equal to half sine A plus B plus sine A minus B. So now I can clean this. Okay, now the next thing to do is to subtract. That is one formula. The next one now is equation 1 minus equation 2. Equation 1 minus equation 2 will give you sine A plus B minus, no, now, but I want you to please pause the video right now and try it by yourself. Try doing it by yourself. 1 minus equation 2. Equation 1 minus equation 2. Try doing it by yourself. Okay, but I'm just going to continue. We have sine A plus B minus sine A minus B. Okay, this is now equal to sine A cos B plus sine B cos A minus bracket open sine A cos B minus sine B cos A. Open your bracket, we have sine A cos B plus sine B cos A minus sine A cos B plus sine B cos A. Sine A cos B will cancel out with sine A cos B here. True or true? True. This is equal to 2 times sine B cos A. 2 times sine B cos A cos sine B cos A plus sine B cos A. That's 2 times sine B cos A. So if we now join them together, we have sine A plus B minus sine A minus B is equal to 2 times sine B cos A. Half both sides, we have half sine A. Let me write it up here. Whoops, 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 whoops. Divide both sides by half, we have sine B cos A. Or rather, let's put the A in front. Cos A sine B is equal to half sine A plus B minus sine A minus B. What I did was put the cos in front because I want A, the term with A to be in front. Here the term with B is in front, not the term with A to be in front. So instead of sine B cos A, I made it cos A sine B is equal to half. I divided by 2, half sine A plus B minus sine A minus B. So we can now clean this. I believe that is good enough. So I'm going to clean this right now. Okay. Clean this. Now the next one now is, since we have done with 1 and 2, we've added 1 and 2, we subtracted 1 and 2. The next one is 3 and 4. Let's add 3 and 4. Equation 3 plus equation 4. Whoa. Equation 3 plus equation 4. Question 3, by the time you add, you have this is equal to cos A plus B plus cos A minus B. This is equal to cos A cos B. Oh, minus cos A plus B is going to be cos A cos B minus sin A sin B plus cos A cos B plus sin A sin B. This is equal to 2 cos A cos B. Cos A cos B, cos A cos B plus cos A plus B is 2 cos A cos B minus sin A sin B. We cancel out with sin A sin B. Okay? So now let's write that together. Write that down together. We have cos A plus B plus cos A minus B is equal to 2 cos A cos B. C'est clair? Oui, c'est clair. Am I correct? La 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 la. Yeah, okay. So now we can just divide by 2. Then we come back here. We have cos A cos B is equal to half cos A plus B plus cos A minus B. Wow. The next thing we do is to subtract. We have equation 3 minus equation 4. This is cos A plus B minus cos A minus B. Cos A plus B is cos A cos B minus sin A sin B minus bracket open cos A cos B plus sin A sin B. This is equal to cos A cos B minus sin A sin B minus cos A cos B minus sin A sin B. Minus cos A, minus cos A cos B will cancel with cos A plus B, leaving you with minus sin A sin B minus sin A sin B. That is this minus this. This is equal to minus 2 sin A sin B. If we join them together, we have cos A plus B minus cos A minus B is equal to minus 2 sin A sin B. So we can now join. Okay, we can now join the two of them together as normally right in this part we just leave that minus sin A sin B. But I really don't know how this question will put it, the option, so I'm not going to divide by minus 2. I don't know why I say that some people will divide by 2, leaving you with minus sin A sin B. But because I'm not sure how to put the question in the option, I'm going to just divide by minus 2. So divided by minus 2, I left with sin A sin B is equal to minus 1 over 2. I told you I divided by minus 2, not those 2. So we have minus 1 over 2 times cos A plus B minus cos A minus B. Yeah, we have that. You can still write this as half cos A minus B minus cos A plus B. Let's make sure that the minus is inside and not outside. That I switched here. Make sure that the outside, the minus is inside and not outside. But in maths, I noticed that there's no math that people are saying that remove the minus sign from the front. You know, I told you that every time we always like when the minus either inside than for the minus be outside. But in all the maths that people have seen, I've not seen anybody actually write it in this form. So I'm very sure the reason why they did that is so that it will not confuse us. Because there's another identity like this bar, but it's in the form of maybe sine, in the form of sine, I think sine x plus y divided by 2, something like this. Sine x plus y divided by 2 times cos x plus x minus y, something like this, divided by 2. There's another identity like this. So I'm very sure the reason why they did that to not confuse this for us. So they write it in this form. Only in this form. But what I'm trying to say with that is that in case in the options you saw something like half times cos A minus B minus cos A plus B, then that would be correct. But most times you just write it in this form, you write it in the other second form. So now that I've gotten this code, enough I'm standing, I got my Bluetooth to show, but let me try my best to stand like a normal human being. I think I hope I did that. So let me check my footage, see if I messed myself, manipulate myself. Okay, simply. Yeah, I not give myself. My bomb will not show. It shows, but not that much. Okay. Telegram message. I'll answer later. Okay. How many viewers are watching? One. I'm not sure. I'm confirmed from here. There. Only one. Okay. Let's clean this because it's not necessary again. Let's clean this. Let's clean this. Let's clean this. Let's have it. Let's have it. Let's have it. Boom. Now we have our four identities proven from the four axioms. Okay. Let's go to our options. We have option A. Let's write our truth table. A, B, C, and D. Let's start killing before you to flag me as saying bad word, but let's start removing some options. The first option we have there is cos A cos B. See cos A cos B here. Cos A plus B is equal to half, correct? Cos A plus B, correct? Minus cos A minus B. No, it's supposed to be plus cos A minus B. So option A, wrong. Next option is B, sin A sin B. That is sin A sin B. That is this one. Sin A sin B is equal to half. Okay. They actually represented it in this form. Remember when I said that most masters group they don't represent it in that form. Our teacher actually represented it in this form. That is, here is supposed to be minus half times cos A plus B minus sin A minus cos A plus B. You put the minus inside, so that just going to be half bracket open cos A minus B minus cos A plus B. That is like saying minus bracket open x minus y. This is like saying y minus x. Minus x minus y is equal to y minus x. So that's what you did here. Instead of cos A plus B minus cos A minus B, now turns cos A minus B minus cos A plus B. So that's how they present. I don't actually use my first time. No, using my first time, but I wrote the test, but like I'm not using it in that way. I will always think that all masters will always leave it like this. But our master made it more confusing and put it in this form. But it still works. Okay, so that is option B. And option is correct, so option B is correct. Option C now we have sin A cos B. Sin A cos B, that is this one. Sin A cos B is equal to half, correct? Sin A plus B, correct? Plus cos, okay, here they say cos A minus B, it's supposed to be plus sin A minus B, not cos A minus B. So option C, X. Then D now we have cos A sin B. Cos A sin B, cos A sin B, that is this one is equal to half, correct? They say in the option they say cos A plus B, it's supposed to be sin A plus B. So this is wrong. So the only option is option B. So that is solution to question 9. Question 9 is option B. Now let's move on to the next question. So these are your identities, your three identities. Will you need them later on? Let me check. Yes, you will need them in the next question. So I'm not going to erase them. I'm not going to erase it. You will need this one in the next question. So let me just erase the rest. If you need more clarification, please you can comment it down. If you need more clarification, if you need more something to say, please you can comment down. You can also meet me in person, and I believe I will also answer your question. And that person I trust in with my viewers because I love my IgweMinions. All the people that do all the people that watch IgweMatics and support me. I love you all more than any other thing. So another person I can trust you guys in. Yes, a viewer. Good evening. Oh, my dad. I told people that it's always him. It's always the person that always to view. People don't like viewing. People watching now. So yeah, my dad. Good evening, everyone. Let me say good evening, sir. Good evening. Wow. Yay! Likes will be 100%, nothing. Okay. The next question is question 10. It says sin 15. Sin 15 cos 30 plus cos 15 sin 30. The first thing you do to solve this question, right, is to check what does this look like. If you are seeing sine cos plus cos sine. If you check, you are seeing sine cos plus sine cos. Okay, but like the thing comes up here, so this one just go like cos A sine B. You are seeing sine cos plus cos sine. So these two are going to be the same. So let's compare. Sine here is sine 15, here is sine A. So A must equal to 15. Yes, cos 30. Yes, cos B. So B must equal to 30. Let's keep on going to confirm. Yes, cos 15. Yes, cos A. So A is still equal to 15. Good. Yes, sin 30. Yes, sin B. So B is still equal to 30. So this must be it. This one, this identity here. This identity, equation 1, must be the identity that we're comparing with. So if we put in A equals to 15 and B equals to 30, hey, I think the question. But anyways, if you put in A equals to 15 and B equals 30, we have that is equal to sine 15 plus 30. 15 plus 30 is equal to sine 45. And sine 45, as you all know, is your board is clear now. Good improvement. Thank you. Okay. Sine 45 now is equal to the square root of 2 over 2 from a special special angles. Now, I did not show special angles in the last video, so I'm going to do that in this video. Special angles. And I said I'm not going to show this video for you to just watch and know how to solve each 15 questions. I want you to be able to solve any question at all that comes at you in this topic. So we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Let's draw our, these are columns. Let's draw our columns. And here we have sine. Let's see x sine x or sine theta. Let us look at sine. We have sine, we have cos, we have tan. If you want, you can also extend it as cosec, sec, and cotangent. Good. Sine 0 now. So you just start. Divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. You always start with sine. I always start with sine. I don't start with that. I always start with sine. So now we start from square root of 0, square root of 1, square root of 2, square root of 3, and square root of 4. Square root of 0 is 0. And 0 divided by 2 is 0. Square root of 1 is 1. And 1 divided by 2 is half. Square root of 2 is square root of 2. And square root of 2 divided by 2 is square root of 2. But this can also be written as 1 divided by square root of 2. Because if you multiply the numerator, no, if you multiply both sides, or if you divide both sides by square root of 2, you get 1 here. And 2 divided by square root of 2 is square root of 2. So you have 1 divided by square root of 2. Then for this one, you have square root of 3 divided by square root of divided by 2. That is correct. And here now square root of 4 is equal to 2. 2 divided by 2 is equal to 1. So you have 0, a half, root 2 over 2, root 3 over 2, and 1. For cos, you just flip them. You flip them for cos. So if sine here is 1, cos here will be 1. If sine here is root 3 over 2, cos here will be root 3 over 2. If sine here is root 2 over 2, cos here will be root 2 over 2. If sine here is 1 over 2, cos here will be 1 over 2. If sine here is 0, cos here will be 0. Easy peasy lemon squeezes. So now, the next thing is tan. Tan is equal to what? Tan is equal to sine over cos. So tan theta must equal to sine over cos. 0 divided by 1 is 0. 1 over 2 divided by root 3 over 2 is the same thing as 1 over 2 times 2 over root 3. 2 will cancel out, leaving you with 1 divided by root 3. 1 divided by root 3. This can also be written as root 3 divided by 3. But most people don't as 1 divided by root 3. Okay. The next one is this divided by this, and that is 1, because this is the same thing. Next one is this divided by this, and that is root 3. Next one is this divided by this, and that is undefined, or just leave it as undefined, or new. Good. Another way to express this tan theta is you divide by 3, divided by 3, divided by 3, divided by 3, divided by 3. Here now you have square root of 0. Am I correct on what I'm doing? Yes. Here you have square root of 0, here you have square root of 3, here you have square root of 3. No, I know what I'm doing. Yes, you have square root of 9 here, not square root of 3. Here you have square root of 9, here you have square root of 27, and here you have square root of 81. Square root of 0 is 0, and 0 divided by 3 is simply just 0. Square root of 3 over 3 is the same thing as 1 over square root of 3. I should have to rationalize for this one. Square root of 3 over 3 is the same as 1 over square root of 3. Square root of 9 is 3. and 3 divided by 3 is 1. Square root of 27 is 3 root 3. 3 can cancel out, leaving you with 3. Square root of 81 is 9. 9 divided by 3 is 2. But we write that as new because undefined. So that's basically it. This is the more practical way, guys. Just divide this by this. But in case you have forgotten, you can just do that divided by 3 with 0, with 3, with 9, with 27, and with 1. Okay. For cosec theta or cosecant, you do 1 divided by sine. So 1 divided by sine is new. 1 divided by this is 2. 1 divided by this is 2 divided by root 2, which is simply just root 2. 1 divided by this is 2 divided by root 3. 1 divided by this is simply just 1. This can be written again as 2 over 3 root 3, but it's not that pretty, so just write it as 2 divided by root 3. It's not all surds that are ugly. Some surds are better off than their actual number. It's better to see 2 divided by root 3 than to see 2 divided by 3 times root 3. It's better to see this. So now you do the same thing for sec. You have 1, you have 2 over root 3, you have 1 over root 2. No? You don't have 1 over 2, you have root 2. You have 1 over root 3. No? You have 1 over 2. No? So you have 2. You have 2 and you have name. That is, you flip them. 1 here, 2 over root 3 here, root 2 here, 2 here, and new here. Therefore, of course, now you're not going to 1 over tangent. That is 1 over 0, that is new. 1 over 1 over root 3, that is just simply just root 3. 1 over 3, that is 1. That is you flip for tangent to flip tangent. So new is here, root 3 is here, 1 is here, 1 over root 3 is here, and 0 is here. So this is your truth table for all the identities. Let me see if that all shown in the video. Yes, like, share, pin a comment, your comment obviously. Okay guys, like, share, and subscribe, pin your comment. Pin message. Okay. Yeah, that pinned. So I started with 9 subscribers, no extra subscribers. Okay. This is going to be your truth table for everything. Yeah, everything showed. So this is your truth table. This is how you do the truth table. Or not truth table, I don't know what they call this table, but this is how you do the table. So now let's clean. I don't think you need this anymore. It's already 7:43, 8 o'clock sun. So we don't need this anymore, so we can clean. What I should have done was to say the words just in case my marker was not clear. I said the words, but I forgot. I already said them. Perfect. Next question is question 11. Thank God for how far we've gone. Question 11, we have sine 4 pi over 3. Now, to solve this question, I always told my dormmates, or my papa not wasting my dormmates, but them I have, them and all. So, I always told them that I'm never going to solve this question in terms of pi. The only question, I'm going to change it to degrees. I don't like radians, truth to be told. Radians is important because of it allows us to solve in terms of a number, because pi is a number. It allows us to solve in terms of a number instead of solving in terms of degree. Instead of solving in degree, it allows us to solve. Whoa, I've made issues this morning. Damn. It allows us to solve in terms of a number instead of solving in terms of degree. But I really don't like degree. I'm used to my truth table. I'm used to 30, 60, 0, 45, 36, and 60, and 90. So I'm used to that already. So let's change this to degrees. We have 4 over 3 pi is equal to 4 over 3 times 180 degrees. Because pi is equal to 180 degrees. And this is equal to 3, we can see here that is 60 degrees. And this is equal to 240 degrees. 240 degrees. So now all we are looking for is simply just sine 240 degrees. Even in your sleep, I'm very sure you're able to see. Oh my god, I hope you're showing. Yeah, it's showing. Okay, showing. So all we're solving for here is just sine 240 degrees. Now if you draw your quadrants and you put your arc, I've seen somebody say SAT, that is sine all cos and tan. But the way my teacher taught me, Mr. Kingsley Solomon, I can still remember your name. Even though I know you don't want for YouTube videos, but yeah, shout out Mr. King Solomon. Mr. King Solomon. The way he taught me was art. You have all, you have cos, no, yes, you have tan, and you have sine. So in all, both sine, cos, and tan are positive, positive, positive. In art, sine, cos, tan, sine is negative, cos is positive, and tan is negative. In this tan place, sine, cos, tan, cos sine is negative, cos is negative, and tan is positive. In sine place, sine, cos, tan, sine is positive, cos is negative, and tan is negative. What I don't really know if I should explain to you the reason why we have positive and negative, but let me just do that. If you have an angle here, this is the positive y-axis and this is the and this is positive y-axis. So all angles here, sine, that's opposite of hypotenuse. The opposite of hypotenuse. Let's have sine. We're going to use sine to get the rest. Okay, but let's use sine and then sine and cos. Let's use sine and cos. Opposite of hypotenuse. Mm, mm, Oh, sure. I'm some something. Let's use the opposite. Let's use sine. Sine theta is equal to opposite of hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to sine over cos. Opposite here is this part. And this line is positive because y is positive here. So this is positive. And the hypotenuse too, that is this length, is also positive. So this is going to give us positive. For cos now, the adjacent, which is this line, is in the positive x-axis, so that's positive. The hypotenuse is positive, so this is equal to positive. For tan now, tan is equal to sine over cos, that's positive over positive, which is equal to positive. That's why we have positive, positive, positive. Clear, clear. Let's go for the next one. Hey, I shall not finish sine. Sine theta is equal to positive over hypotenuse. Okay. For the next case, this quadrant, we have sine is positive in this case. If we draw the line, this is our angle here. If we draw our line, opposite now in this case is still in the positive y-axis, so we have plus. The hypotenuse in this case is still plus, and this is equal to plus. For the other side now, we have this line. This is the negative x-axis. So our other side is negative over our hypotenuse, which is plus, is equal to negative. And our sine is equal to our tan theta is equal to sine over cos. Sine is plus, cos is negative. Plus divided by negative is negative. That's why sine is plus here, cos is negative here, and tan is negative here. Let's go for the third case. For the third case now, we have sine as this line here, the degrees here. The opposite is in the negative y-axis. So we have negative y-axis divided by our hypotenuse is still positive. Hypotenuse is always positive. Like this line is always positive. It's a positive line. So it's equal to negative. Cos is adjacent, and adjacent is the negative. So we have that is negative x-axis. So we have minus divided by plus, which is equal to negative again. But tangent now is equal to negative divided by negative, which is equal to positive. So that's why sine is negative, cos negative, and tan is positive. For the last case, we have the line here, we have the angle here. The opposite is negative, that is negative y-axis. The hypotenuse is positive, and this is equal to negative. Cos is adjacent, and adjacent is positive because in the positive x-axis here, positive divided by positive, and that is equal to positive. For tangent now, we have negative divided by positive because sine over plus, and that is equal to negative. That's why here we have sine is negative, cos is positive, and tan is negative. So that explains that. Now that I've explained what that table is, we can now solve this question. 240 is in the third quadrant because from here we have 0 less than or equal to theta less than or equal to 90 and theta is equal to theta. Here we have 90 degrees less than or equal to theta less than or equal to 180 and theta is equal to 180 minus theta. Here now we have theta is equal to that is 180 degrees less than or equal to theta less than or equal to 270 and theta here is equal to 180 plus no theta here is equal to theta minus 180. Here now we have 270 is less than or equal to theta is less than or equal to 360. And theta is equal to 360 minus theta. Perfect. So now we know that 240 is going to be inside this quadrant because 240 is in between 180 and 270. So 240 is inside this quadrant. So sine 240 is in the third quadrant. Sine is negative here. Don't forget, sine is negative here. So this is equal to minus sine. The theta now is equal to theta, which is 240 minus 180. 240 minus 180, that is 40 minus 8, 60. So this is going to be minus 60. So sine 240 is equal to minus sine 60. From that truth table that I showed you, sine 60 was what? Root 3 over 2. So 2 sine 240 is going to equal to minus root 3 over 2. And that is option C. Option C. Let's go to question 12 now. Are you ready? Is on 12? Any comments? Okay, catch up. Pin a comment, guys, subscribe. Heavy rain just started in my location. I need to find my bed now. Catch you tomorrow. Keep going. Thank you. Okay, more likes. How long has the stream been going? You're welcome. Okay, Jameson just came online now. 2 hours, 6 minutes. Okay, you're welcome. Jameson just came online. Okay. Let's keep going. Let's go to question 12 now. We finished with this question. I'm sure I've dealt with it well. Let me make sure. Okay. I thought my face was not showing. Okay. It's showing. Everything's showing. Everything showed. Okay, let's move on to the next question. I didn't actually expand the whole thing. So I'm going to show you what I did planning the whole thing. But question 12 says now this part. This part is all those expansion. Let me guess. Yeah, this part is all those expansion. Father Lord, please, as I've come thus far, any error that I'm about making, please Lord, let the errors be unmade. Let the errors not occur because this part is very crucial. Any small mess up and I've messed the whole process up. Mess up. I don't want time to boost myself. Okay, question 12 now. We have x minus 1 over 2, x minus half to the power of 5 in ascending powers of x. Now, first of all, before I do this, I'm going to first of all expand it. Then show you how I cancelled out in the options. I'm going to expand it as normal. So we know that when we have a plus b to the power of n, this is equal to the sum of I from R from x. From R. From R equals to 0 to n, okay, of n combination R, okay, a to the power of R, a to the power of n minus R, b to the power of R. Perfect. So you are summing from R equals to 0 to n of n combination R times a to the power of n minus R times b to the power of R. So let's use this formula to expand this. So we have a is equal to x and b is equal to but we have a equals to x and b equals to minus a half. So this is equal to when r equals to 1, we have 5. Let's just put the parameters first of all. A equals to x, b equals to minus a half, and n equals to 5. So we have when r equals to 0, we have 5 combination 0 times a to the power of n minus r, that is a to the power of 5, times minus 1 over 2 to the power of 0. This is summation, so the next thing is plus. By adding, the next case is when r equals to 1, this is 5 combination 1 times x to the power of 4 times minus 1 over 2 to the power of 1. Let me just write it here. I don't stand up. We have 5 combination 2 times x to the power of 3 times minus 1 over 2 to the power of 2 plus 5 combination 3 times x to the power of 2 times minus 1 over 2 to the power of 3 plus 5 combination 2 times x to the power of 1 times minus 1 over 2 to the power of 4 plus 5 combination 2 times x to the power of 0 times minus 1 over 2 to the power of 5. Okay, now let me explain what combination is. I'm not going to explain the use of combination on others, but I'm not going to explain to you how to evaluate combination. If you have n combination r is equal to n factorial divided by n minus r factorial times r factorial. N factorial now is equal to n times n minus 1 times n minus 2 times 3 times 2 times 1. With that idea, 5 combination 0 will equal to 5 factorial divided by 5 minus 0 factorial times 0 factorial. 5 factorial is equal to 5 factorial and 5 minus 0 factorial is equal to 5 factorial. 5 factorial times 5 factorial, so that is equal to 1. So we have 1 times, let me use brackets of normal times. We have 1 times x to the power of 5 minus half the power of 0 is just 1, so that's times 1 plus 5 combination 1 is 5 factorial divided by 5 minus 1 factorial times 1 factorial. This is equal to 5 factorial divided by 4 factorial times 1 factorial. This is equal to 5 times 4 factorial divided by 4 factorial. 4 factorial cancel here, leaving with 5. So all this is equal to 5 times x to the power of 4 times minus 1 over 2. Plus, the same thing goes here, we have, okay. Since we have come this far, let me give you a little bit secret in this expanding bracket. When you're expanding bracket, right, you see the power of a here, a is power of 5 here. You do 5 times 1 is 5, divided by 1, you get 5. You do 4 times 5 is 20, divided by 2, you get 10. So the next number here will be 10 times x to the power of 3 times minus 1 over 2. 1 over 2 squared is going to be 1 over 4. The next one now is plus. 3 times 10 is 30, divided by 3 is 10, plus 10 bracket x to the power of 4, bracket open, minus 1 over 2 to the power of 3, that is minus 1 over 8. The next one is plus 4 times 10 is 40. 40 divided by 1, 2, 3, 4. 40 to no. Oh, hey, that's right. Yes, supposed to be 2, not 4. Yes, supposed to be 2. 5, 4, 3, 2. Yes, supposed to be 2. 2 times 10 is 20. 20 divided by 4, that's 5. Plus 5 bracket x to the power of 1. Minus 1 over 2 to the power of 4 is 1 over 16. Plus 1 times 5 is 5. 5 divided by 1, 2, 3, 4, 5. 5 divided by 5 is 1. So this time plus 1 times x to the power of 0 times minus 1 over 2 to the power of 5 is minus 1 over 32. So you just sum everything up, and you get x to the power of 5 times 1 is x to the power of 5. X to the power of 4, 5 times minus 1 over 2 is minus 5 over 2 x to the power of 4. Is that how they did it? Okay, no, I think they did their own. They said in ascending power of x. Okay, I'll complete that. I will explain that later. Okay, minus 5 over 2 x to the power of 4. 10 divided by 4 is 5 over 2, yes. So we have plus 5 over 2 x to the power of 3. 10 divided by minus 8, you have minus 5 over 4 x squared. 5 divided by 16, you have plus 5 over 16 x plus minus 1 over 32. Good. So this is equal to this. It's not here. This is another solution. This is the first one. When r equals to 0, when r equals to 1, when r equals to 2, when r equals to 3, when r equals to 4, when r equals to 5. Okay, this was before 5 combination 4 and 5 combination 5. When r equals to 1, 2, 3, 4, and 5. We have this and this now. By the time you put the brackets, it simplifies to this. X power 5 minus 5 over 2 x power 4 plus 5 over 2 x power 3 minus 5 over 4 x power of 2 plus 5x divided by 16 and minus 1 over 32. But the question says that we should do it in ascending power of x. If you notice, x is reducing. We have x power 5 here, we have x power 4, x power 3, x power 2. So we have to flip them so that x will be increasing. And if we are flipping them, it will be minus 1 over 32 plus 5 over 16x minus 5 over 4x squared. Yes, ascending power plus 5 over 2x cubed minus 5 over 2x power 4 plus x power 5. If you notice this, that will be option B. Minus 1 over 32 plus blah 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 blah. That's option B. Now, as I said, the purpose of this video is for simplification, faster method. We're looking for the quickest way to solve. So I'm going to show you a shortcut to solving this question. And I want you to pay rapt attention. And it's simply just by second guessing what you have to expect. We already know what the first term and the last term will be. If you look at the first term here, we have x. So the first term should be x. No, the first term, sorry, since it's ascending power of x, the first term we have minus 1 over 2. So the first term after you have expanded should be minus 1 over 2 to the power of 5. That's minus 1 over 2 here to the power of 5. Because that number will always be 1. That coefficient will always be 1. So you have minus 1 over 2 to the power of 5. Minus 1 over 2 to the power of 5 is what? Minus 1 over 32. If you check the option C and D is plus 1 over 32 and not minus 1 over 32. So automatically, if you have A, B, C, and D, automatically option D and C are cancelled. You are now left with option A and B. Option A and B now, and now we are left with you have minus 1 over 32 plus blah 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 all the way down to plus x power 5. Now, how do you pick between option A and B? If you check the expansion, this minus 1 over 2 should move, the coefficient should move from 1 over 32 to 1 over 16 to 1 over 8 to 1 over 4, 1 over 2, then 1. That's how the expansion shall look like normally. But because of the coefficient, don't forget that this expansion has coefficients of n combination r. So because of that coefficient, these numbers will be reduced. There's 1 over 32, 1 over 16, 1 over 8, 1 over 4, 1 over 2, and 1. The numbers will be reduced because of this n combination r. And if you check from here, if you notice, 10 here will reduce this 1 over 4, and it gave us 5 over 2. 10 here will reduce this 1 over 8, and it gave us 5 over 4. Okay, this one is 5, so you don't reduce anything. But these terms that appeared, reduce these middle terms. So when you are seeing terms 2, 16, 8, and 4 and 2 in option A, it's going to be wrong because something is reduced. But option B, now you are seeing that reduction 32, 16, 4, 2, 2, and 1. And that's what you are seeing here 32, 16, 4, 2, 2, and 1. So there's no way I can actually solve this. I just use that pattern knowing that we're going to reduce for those middle terms, and I put it here as option B. So let's go to number 13. Possibly because of time, I don't know if we're going to solve question 15. Which question 15 that all of you are all may be waiting for. But I'll try my best to finish solving question 15 now. If I can't solve question 15 now, then in hostel, I would make sure I record the video, then go downstairs to upload the video. Good evening, sir. Wait downstairs to upload the video immediately. I can upload it, sir. Okay, question 13 now. It says, expand this question as I finish the example. People are just telling me the question had none of the above as correct answer. I said, you have none of the above as correct answer. How? This question actually has an answer. There's only one question in this whole exam that the answer is none of the above. So that none of the above, as I said in the last video, that none of the above is to confuse you. That none of the above is to confuse you. That's what knows what it's doing. It's to confuse you. Try your best not to be confused. Don't just be picking none of the above, none of the above. In secondary school, let me not lie, I was the none of the above picker. Anytime I see none of the above in the question, I know that teacher put none of the above there because there was actually no answer. Anytime I see all of the above, just they don't need to solve, just put me all of the above because that was the answer. For the teacher to put all of the above, all of the above. But that's what they are. But university know that they know inputs plan, they know how this thing works. I'm not waiting for the time. I'm not going to say with my own mouth, but I'm still going to say it. But I'm waiting for the time that physics teachers will stop giving us units. Because in secondary school, units, whenever you don't understand something in physics, you carry the unit of the options. Now put it back inside the question and find a way to make the units work, then multiply. Because me, if I do that thing. I'm not waiting for the time that physics teacher will stop giving us units and start giving us the answer. We'll see how we'll survive. But now that our masters have seen this thing, that we're always picking on the above, they put none of the above in all the options. So in case they give you a question that cannot be solved, it's just wisdom. So let's just try. Let's just go. We have 2x minus 1 over 2 to the power of 7. The question says, what is the coefficient of x to the power of 4 and x to the power of 5? Now, I want to tell you, if you don't know if you don't know this method, or if this method will confuse you, then please, what you should do to avoid confusion, expand it. What you should do to avoid confusion is expand it by yourself. Expand this fully. I know this x power of 7, but it's better you get mark after sweating than to get 0 for guessing. So since you don't have to, I'm going to teach you the method. If you still understand what I'm going to say now, just expand it normally. The way I showed you before, just expand it normally. But to get this method back, you first of all put it in the form of the each term. I thought each term will be n combination r times a to the power of n minus r times b to the power of r. Yeah, now n is equal to 7, a is equal to 2x, and b is equal to minus 1 over 2. So you put all those things inside here. We don't know r yet, but we put all them inside here. We have 7 combination r times 2x to the power of 7 minus r times minus 1 over 2 to the power of r. So now we're looking for the one that will give us x to the power of 4. To find the one that will give us x to the power of 4, right? You check for the power of x here. The power of x here is x to the power of 7 minus r. If there was x here, let's say the x here was maybe x to the power of r, right? What you do now is by the time you have x to the power of r here, you now multiply. So no. Let's say x plus x to the power of minus 1. So by the time you have that power of r here, it will now be minus r. So you have x power of 7 minus r times x power of minus r. You can now join it together as x power of 7 minus 2r, and that will be the degree of r in this expansion. But in this case, the equation is actually simpler. It's simpler. We have just x to the power of 7 minus r is equal to x power of 4. Cancel out the value of x. We have 7 minus r is equal to 4. Simplify. We have 7 minus 4 is equal to r. We have r is equal to 3. So that's the first value of r is equal to 3. The second thing they say you should find is when x is x power of 5, not when x equals to 5, x power of 5. So we have x power of 5 here. So you compare again. We have x to the power of 7 minus r is equal to x power of 5. X will cancel out, leaving with 7 minus r is equal to 5. R comes here, 5 comes here. We have 7 minus 5 is equal to r. That means r is equal to 2. R is equal to 2. So these are the two cases that we're looking for. We're looking for when r equals to 3 and when r equals to 2. So instead of expanding the whole thing, you can just put them singly for this r equals to 3 and r equals to 2. Instead of finding r equals to 0, 1, 2, 3, 4, 5, 6, and 7. You can just W's in the chat. Who is this? Shout out to at LITHSFF2194 for joining the live stream. I hope you understand. Please, if there's any question, please ask in the comment. So, first of all, let's try my best to finish up question 13 and 14 so that I'll handle question 15 because question 15 is a very powerful question. Very, very powerful. I sweated. Let me know that I sweated. So, question 15, we put in, for this question 13 now, we put in my r equals to 3 into this formula. We have 7 combination 3 times 2x to the power of 7 minus 3 times minus 1 over 2 to the power of 3. This is equal to 7 factorial divided by 4 factorial times 2 factorial times 2x to the power of 4 times minus 1 over 2 to the power of 3. This is equal to 7 times 6 times 5 times 4 factorial divided by 4 factorial times 3 times 2. 4 factorial will cancel out, 3 times 2 will cancel out with 6, leaving you with 35. This is times 2 to the power of 4, that is 16x to the power of 4. Minus 1 over 2 to the power of 3 is equal to times minus 1 over 8. 8 here will cancel here, leaving you with 2. So you are left with times minus 2x to the power of 4. Minus 2 times 35, that is minus 70x to the power of 4. So the coefficient of x power of 4 is minus 70. Option D. There's something that one of my dormmates told me. He said that whenever he saw this kind of questions, and I told that time, like, if you have an option, like, if you are given those options, right, and you've gotten one of the values, that is maybe one of the values, there's no need to solve for the other value. There's, if your choice, if you have time, you can solve for the other value. But if you don't have time, just pick the answer. So option D now has minus 70 for the coefficient of x power 4. There's no need to solve for the coefficient of x power 5 when there's no other option there with minus 70. If the let's say option A was minus 70 and 128, then you can solve for the question of x power of 5. But in this case, since minus 70 is the only option there, is only since D is the only option of minus 70, then this is correct. But just for the sake of in case this, let's solve for when r equals to 2. When r equals to 2, we have 7 combination 2 times 2x to the power of 2, no, times 2x power of 7 minus 2 times minus 1 over 2 to the power of 2. 7 combination 2 is equal to 7 factorial divided by 5 factorial times 2 factorial times 2x to the power of 5 times minus 1 over 2 all squared. 7 factorial is equal to 7 times 6 times 5 factorial divided by 5 factorial times 2 times 2 to the power of 5, that is 32, x power of 5 times minus half to the power of 2 is equal to 1 over 4. So 5 factorial cancel out 5 factorial, 2 here will cancel out 2 here, leaving you with 35 times, okay, 4 will cancel out 4 from here, that was leaving you with 8, I think. 4 here, 16, 8, yes, 8 x to the power of 5. So you have to do 35 times 8, and that is 35 times 8. That's my head. Something of not adding up. 7 times 3 is 21. 7 times 3 is 21. 7 times 3 is not 35. 7 times 3 is 21. So we are left we have 21 here times 8 times x factorial. 21 times 8 is 8. 8 times 3 is 16. So we have 168 x power 5. And that is option D. So we have minus 70, 168. Let's solve question 14. Let me check if there's any comment or question. No, in the chat. Okay, that's all the question. That's all the comments. Thank you, thank you. 3 people watching now. Wow, that's nice. Please share the link. People may want to join. Please share the link and ask comments, ask questions. Sorry. So for question 14 now, what is the coefficient of the third term in the expansion of ax minus 1 over x power of 5 in descending powers of x? Okay, if the coefficient, okay, so I said the coefficient of the third term blah, blah, is the coefficient is 80. Coefficient of the third term, like C of 3, is equal to 80. Coefficient of third term is 80. Then we should find A. You remember when I told you that time that the question I gave us that time was easy? That we have 2x minus 1 over 2 to the power of 7. So all we have to do in our comparison was just 2x to the power of 7 minus r, that's minus 1 over 2 to the power of r. In this case now, we have x here and we have also x here. So we cannot just say x to the power of 7 minus r. We have to also factor the x that will be here. So let's solve this question. Our A, since there's A here, remember I told you that whenever you have A inside the question, and normally when you're solving a question, you use A, you have to change variables. So I don't change variables too much. Even I shall use U or I shall use V, but I don't change variables too much. So I'm going to use capital A. So we have capital A is equal to AX, and we have capital B is equal to minus 1 over X. Our N is equal to 5, and our R is what we're going to look for now. Now, if you don't look for R now, you can solve the whole thing. As you can expand the whole bracket, then pick your third term. But since we don't want to go through too much stress, we're going to look for our value of R. So we have N combination R times A to the power of N minus R times B to the power of R. This is equal to 5 combination R times A is equal to, so this is capital A, this is capital A and capital B. Capital A and capital B. Our capital A is equal to small ax to the power of n minus r, and capital B, like capital B, sorry, is minus 1 over x to the power of r. 5 combination r, okay, is not going to be needed. Okay, we have A, okay. So now I told you have to bring out your x's. Our x here is x to the power of n minus r times our x here is x to the power of minus 1 times r, that's minus 1r. So bring them together, we have x power of n minus r that is equal to x power of n minus 2r. So this x power of n minus 2r is equal to something. Is equal to the third term. Now the third term in this expansion, the first term is going to be x power of 5. The second term is going to be x power of 4. The third term is going to be x power of 3. Now it's x power of 3. It's not the third term because x power of 3. It's the third term because by the time you are doing it in descending power. Descending power, yes, in descending power, we have 5, 4, then 3. So if I ask you for the second term here is 4. You can say the second term is not x power of 2. The second term here is 4. If I ask for the first term here is x power of 5 and not x power of 1. So just because it's the third term and does not mean that it's x power of 3 every time. If I told that this is 7, that was here was 7. Let's assume that here was 7. Then your third term is x power of 7. Sorry, x power of 7, x power of 6, then x power of 5. So your third term will be x power of 5. You can see your third term here is x power of 5. So when I say that your third term here is x power of 3, it's not because okay, your third term, so every single time your third term is x power of 3. No. It's not every single time your third term is x power of 3, but this time coincidentally, your third term is x power of 3. Cancel out your x's, you have n minus 2r. Sorry, you already know what n is. All these n's are supposed to be 5. We already know what n is. So we have 5 minus 2r is equal to 3. Compare, collect like them, they have 2 is equal to 2r. So r is equal to 1. Oof. No. R is not equal to 1. 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 Cn, right? N. That n10 is equal to r minus 1. N10 is equal to r minus 1. So if n is equal to 1, r is equal to r plus 1. Okay. It's not all these things that I don't revise the question before I do these videos. So it's like that as I'm doing the video that I'm solving. So it's like I'm solving in an example. So it's not like I have the knowledge of comment here. I need the exact question. Oh no, I think that you will have your question with you. But if you meet me in hostel, please meet me in hostel or message me +234 8087 6012. Please message me on Telegram or WhatsApp. I'll send you the picture of the question. But I expect you to have your question, but you can message me for the question. Okay, let me try that again. The nth term is equal to r plus 1. If we're looking for the third term, so that's 3 is equal to r plus 1. So r is not equal to 2, not r equal to 1. That method I told you now is when you tell to find the x to the power of 5. Let us say tell you to find the coefficient of x to the power of 5. Then you use that method I showed you here. When they find the coefficient of x to the power of 5, you use that method I showed you before. But when they tell you to find the nth term, you use nth term is equal to r plus 1. That is because when you're finding the next term, you remember you always use r equals to 0. So r plus 1 is going to equal to 1. So that is the first term. When you're finding the second term, use r is equal to 1. So r plus this thing, what do you call it? 1 is going to equal to 2. So you're finding the third term, use r is equal to 2. R plus 1 is going to equal to 3. That's the third term. So nth term is equal to r plus 1. So I find the third term is equal to r plus 1, that means r is going to equal to 2. If r is equal to 2 here, we have 3, is it 3? No, this is 5. We have 5 combination 2 times ax to the power of 3. 8 o'clock. Okay, sir. Oh, sorry, 8. As you want to go now. Okay. This question is last question. I'll solve question 15 still. Okay, we have 5 combination 2 times 8x to the power of 3 times minus 1 over x to the power of 2. 5 combination of 2 is 5 factorial divided by 3 factorial 2 factorial, that is 5 times 4 divided by 2 factorial, that is 10 times a power of 3 times s power of 3 times minus 1 over no minus cancel out, that was x squared. X squared here, x here, that's x. So we have 10a cubed is equal to 80. 80 is the coefficient of the third term. So sorry, we have 10a cubed is equal to 80. Divide by 10, we have a cubed is equal to 8. That means a is equal to 2. A equals to 2 is going to be our answer, but there's no a equals to inside the option. So our answer is E, none of the above. So please, in the hostel, I will do question 15, which is the hardest question, basically. So I'm going to just do a full video on that. There are two methods that I got to solve that. In the exam hall, I did one method, and I want to say thank you to Bernard, because in at home, it was doing I was practicing for GET, doing that's my doing GET assignment when Bernard, why am I calling his name? Sorry, sorry for calling your name out. I'm sorry. I know his name, but one of my dormmates, he sent a video. So I sent a question, 15 questions to the group. I said, who will solve this? But unfortunately, I was not my own so I did not solve it for him. And I did that for the but I saw beat me to it. My dad call is Saturday too. But all in all, things on things, it's because of the question that my dormmate sent that I was able to solve this question 15. So I used that method in exam, but after the exam, I met another of my dormmates and he showed me another method. I'm going to show you the two methods. So it's you that will pick the one that you prefer. My own method relies around pattern. His own method relies around this thing, what they call it, expanding. That is, you have to expand the x power of 5. That is, expand that to the power of 5, which I feel is more hectic, but whichever one you prefer, you would use. Thank you for watching the live stream. I would like the live stream to go on for some time as I return everything back to its rightful places. Hey, my tablet self was on there self. I forgot. 9%. I knew. Thank you, tablet, for surviving with me as I put you through too much trauma today. I didn't know I was going to do this video. I didn't move on my charger. Avoid confusing everybody for question 15. I'm going to attempt. I'm coming.